a bit of a journey. So sorry. We're on our third laptop, but we are working now. Welcome to the second day of State of Open, the security track, which is the best track. I am going to be talking today about fixing open source cybersecurity by 2030. Originally, this talk was going to be regulation by telemetry, basically stating what most of you have heard from me, which is the request from SBOMs is too cloud-centric and very difficult for us to execute in real time. I don't want to talk about that today. I think there's more interesting things we can cover. Do check out some of the links that I'm going to be talking about are going to be covering OSSF, some of their working groups, Alpha Omega. And if you look at this links tree, you will be able to access all of those immediately. So where you know me from, I'm a DevSecOps engineer. I come from the security clearance space from the US, and I primarily was working on real-time anomaly detection, which is the kind of security that I do. I'm not so interested in static security and in static binaries. I'm very interested in real-time events when we're running with large systems. I am a startup tech lead. I've worked with several of you on paid and unpaid basis in the Innovation UK grant space. If you've got an interesting problem to solve, sometimes I do help with that data science. And I am trained in both computer science and in public law, which is incredibly important to understand in a space where we work on licenses. If you know me from open source, I have been a maintainer and an advocate for projects in both chaos engineering, site reliability engineering, and cybersecurity, meaning when I am at work or building things for developers, it's typically aimed at people that have to deal with severe incidents, again, in real time. And philosophically, I only work on what I care about, which is really beautiful in open source, because I'll do that for free. But what I'm working on right now are two problems. I'm very interested in using runtime observability, like eBPF, which you will learn more about later today, in supercomputing to see if we can reduce the carbon cost of those and also raise interesting runtime security concerns. Outside of that, I am an advisor for digital sovereignty for our worlds, which is a native owned and run VR or XR experience, which is fascinating. And in that space, I'm very, very interested. Coming from a tribal reservation space myself, I have a dual sort of responsibility and a dual citizenship, both as a US citizen and as a citizen of my tribal nation. We are trying to surface and tell our stories in an incredibly responsible way. The data sets that we receive from these sometimes do have really, really interesting security concerns or sovereignty concerns. And increasingly, I'm interested in understanding how the underrepresented populations of open source are changing it. And on Linktree, go watch this, because everybody thinks that the original code talkers were Navajo. There was one that happened in the early 1900s, and no one knew that the Choctaw code talkers were the first ones. Why? Because it was wrapped up in security clearance, and we didn't know about it until France came and provided a Medal of Honor to the surviving members of those code talkers, to the Choctaw Nation specifically, not to the US, because it's a different sovereign nation, and they were able, as French citizens, as a French nation state, was able to come in and talk to a sovereign state. So when I say sovereign state, I really mean it. These are political entities, political bodies. Now here's what we're going to learn today. I'm going to give you a run through of how to choose the best open source components with math. It's a nice way to sort of wrap together some of the things we talked about yesterday. Ecosystem hardening, how we need to deal with sort of the cultural approach to this at the maintainer level, and new threats. I think there is a very real threat around the new types of people that are coming into open source, the kind of culture that existed before open source was more corporate than it is now. And I'm going to explain how we need to approach that. Before I do that, let's cover open source licenses basically. Typically, if you're building a product, you're going to have business intelligence, code artifact, and a code-based development, all of which have levels of IP. If you're using open source, you can use any open source that you want, really. Internally, I don't really care. Externally, I really do have to make sure that I am using a standard of license that is appropriate for my usage. As soon as that code can be seen or utilized by an integration or a party, it matters. Now, IP rights and the open web. Intellectual property rights are just the use of creation and the right to your own use as a creator. This is very important for you to understand as maintainers of IP. The public web is the generally open web, but open source and fair use are really interesting in this case. Fair use is just an affirmative defense of copyright, and if you want to know more about all of that, Amanda Brock is the one to talk to. Open source is the license statement of the rights. These are the most common ones. Everyone in this room typically knows what these are. But I always like to bring up this example because I think it's genuinely illustrative, and if you are dealing with anyone in your organization who doesn't understand open source architecture or licenses, tell them to check out Shiv Integer. So Thingiverse allows us to go and get the binaries for anything that you want to build for a 3D printer. And what Julian did was go and scrape everything that was compliant, so everything that had the same license, and create these beautiful random art projects. It's beautiful, it's interesting. That's a way to describe open source architecture to someone who doesn't understand it. But really, it was to demonstrate the ethics and requirements of legality in open source, which is very cool. The last statement that I'm going to have around this, I think, is really important to understand. So copyright applies to all creative work. Trademark identifies a brand. Patent protects innovations. And open source licenses are enabled sharing. Why don't we patent open source? It's very historically simple, because originally these were binaries, zeros and ones, and you cannot patent numbers. That was the beginning of open source licenses, and we have developed a very interesting and, in my opinion, new legal and ethical domain because of that. So, how do we choose the best open source packages securely? 96% of vulnerable downloads are avoidable. How do we avoid those? You can't just put in Dependabot, you can't just make assumptions, because this is increasing year over year. The supply chain attacks, I hate that number. Now, let me tell you a little bit about yourself. If you are a developer, you're going to be pretty confident that you're not using vulnerable versions. If you might be, here's one of the important takeaways from this. Your managers are significantly more confident than your developers are at your ability to handle 0 days. And that's because they are aware of our best practices and whether or not they're in place. So managers do need to have a stronger empathy for these PagerDuty incidents. They do need to understand that one-day remediation is ideal, but you might not be hitting that here. So why are we making imperfect decisions? Because open source is a little bit hard. So 64% are just suboptimal decisions. They're not necessarily very high risk, but they will lead to more developer time in refactoring later, and that's important to me. A really cool way to check out whether or not an open source package is being well maintained and securely maintained is Sonatype's mean timed update. I really, really like this from the research team. What they did here is calculate when an open source package updates with a version, how well did they do, and how often did they update what they were bringing into their dependencies? So it strongly correlates to mean time to remediation, and I think this tells a really, really simple story. Why does mean time to update of your open source package have the strongest predictive relationship to mean time to remediation when none of the other predictive measures that we have out there, source rank, none of them were strongly predictive? MTTU super helps with this. It's because when you are intaking and ingesting open source, you are accepting the risks, but you're also accepting the quality of that maintainers, of that pipeline. And unless you can calculate that quality, you really don't know how to go. So here's some of the options that you can use, and you can use these sort of together as you're trying to decide what is a good open source package. But these early approaches, libraries, IO, and OpenSSF criticality, they're good and they can be used in combination, but individually they're not highly predictive of whether or not an open source package is going to have a vulnerability in 3 to 6 months. Last note on this, MTTU is accelerating. This is incredibly important because the entire open source field is both expanding and accelerating, meaning that it's very likely that you are going to have to update your packages inside or at the same rate as your sprints moving forward. So if you're trying to make these decisions manually, you don't have any dev time left. So Sonatype did this incredible research this year that I thought was really, really interesting. So we've got survey data, download data, app scan data, and OSS security practices, specifically the OpenSSF scorecard that we learned about yesterday. Now, Log4j. I've said, I don't want to talk about this anymore, but we have to, because Log4j and Log4Shell really showed us that when you have a severe vulnerability with this kind of open source surface area, we want to have rapid remediation, but we have not gotten that. In part, there's two different reasons. Yes, because sometimes these are locked inside of your jars and Uber jars, and they're just difficult to scan for. But there's a much bigger concern here that there are a good 35% of Log4j, Log4Shell sitting out there, possibly because there's just a not strong enough awareness of this critical CVE, because we are doing a lot of this zero-day disclosure essentially by Twitter and other social vectors instead of standardizing and centralizing that. This is increasingly changing with some of the implementations that OSSF and the surrounding groups have put in place, but these numbers are drastic and terrify me, because those are open backdoors. Now, my last statement, and if you haven't read the Sonatype report yet, there's a reason why it's been mentioned several times. It's very good. So on average, an open source library is going to have about 5.7 dependencies. Now, if you've got about 150 dependencies inside of your project, we're talking specifically Java here, you could have up to 1,500 updates to consider in a year, and that's just not possible to do if you're doing it manually. So if you want better metrics to predict vulnerabilities, the aggregate measures are here. The aggregate measures open source criticality, security scorecard, library source rate, mean time to update, not meet, and popularity. In combining those, we've got a really good idea of what works best. I just want to step back for a second and explain why some of those factors are highly predictive in the inverse. So it's very easy to think about, common sense. If you have a package that is vulnerable, here's the things that it's probably going to be doing. It doesn't have a code reveal. It doesn't have a binary that I can scan. It pins its dependencies, which is just irritating and bad practice generally, but it's a severe security concern. And you don't have branch protection. So coming out of Sonatype's last year of research, I really found this interesting. How do we predict and inform a consuming open source user? And sitting right there on Maven Central is the Sonatype safety rating. So if you can understand the underpinnings of that, you begin to understand how important it is and how building out these ecosystems of the OSSF scorecard, making sure that those are integrated, making sure that everything's updated in an ecosystem can improve it. Now, this isn't perfect, but it's pretty good. 86% accuracy. So go check this out and read that report if you haven't already, because I left out a lot of cool elements to that. But you want to favor open source packages with smaller dependency trees. Look for ones that have a quick update, a good MTTU, and minimize the total number of dependencies and maintaining low update times, because it's the transitive dependencies that are killing us, right? It's not necessarily that open source package, but it's the fact that that OS package pulls in an OS package that pulls in an OS package that is vulnerable. And if you do this well, you can save yourself money, but for me, as a developer, it's mostly time. This is really irritating toil. Security refactors are irritating, and they have to be dealt with right away, right? And incident events, there's no way to avoid them. So if I want to avoid having to do a security incident refactor in my own corporation, maybe I can just focus on fixing the ecosystem, I thought 2 years ago. And so I joined Sonatype, and I said, all right, let's go out and reach that maintainer class. Let's get some education out there, and let's harden some of these ecosystems that I deeply care about, particularly Kubernetes. So we ran 2 different types of events. We ran a bug bash twice, which is interesting. So we all understand this open source contributor model of having an OS project, a maintainer, and a contributor. Now, what we did was go and do a static scan of the binaries for participating CNCF projects. We gave them a list of known vulnerabilities, and then we worked to bring their contributor base to learn how to solve and harden that package. I think that's really important because culturally we're only incentivized, I mean, not even culturally, we as human beings are only incentivized to work on things that matter to us. So really embedding that education with the maintainers and their strong contributors really worked well. Then we shifted strategy because as I was reaching out and working with these maintainers through the bug bashes, those were successful, good implementations of reducing vulnerabilities for major packages. But there's a lack of education and training and understanding about security in the maintainer class more generally, to the extreme that sometimes I will have to reach out and communicate a 0-day, but I don't have any way to do that for some of these packages. They don't even have a security MD file. So training that really basically became very important to me in Kubernetes. So there's the CLO monitor, which goes through and checks every incubating CNCF project, and it sort of evaluates what their current best practices are. And it gives you a nice little neat score. And I said, wow, there's one project in all of CNCF with a 100% security score. Can we improve that? It's Pixie, by the way. I love Pixie. So this is really neat because it was educational intervention, but we did it in a really creative way. So maintainers got awards, recognition, financial support, faster time to compliance, security enablement. We are pushing an entire cohort of maintainers and projects up through the incubator in tandem, which I think is very important. Number two, contributors got rewards, recognition, and we worked with Google to provide up to $50,000 to the CNCF Diversity Scholarship for every project that got up to 100%. And that was just a really cool cherry on top. But wait, there's more. So we've talked more generally in security, really from that sort of like corporate nation-state protection space. And I think it's very important to understand that the corporate culture of open source is different from open source in the wild. And there are actors and agents and maintainers in open source that will never integrate into a corporate culture, unless they're paid. I found this protestware from Marek really interesting. They put out a bid about a year before they went to shut down their repository, saying, pay me or I'm taking down these 2 packages. And then they DOS'd it. So they put a security, they DOS'd all of their end user. We're talking like a massive surface area when that occurred. Really interestingly here, the sort of solution to this was GitHub Microsoft took this maintainer's repository away from them, and they now own and run that code, not a fork, that repo. The license on that repository did not allow for that to happen. That, I think, is a major fumble. It's clearly illegal. It's just not usually actioned on legally, unless you're Rob Landry. This, in open source in the wild, scared a lot of people because this is a platform acting as a sovereign, acting as if they are not beholden to the rights and obligations of open source licenses. And you can't tell me that GitHub doesn't know what open source licenses are. Sovereignty politic. I think that this is where we need to have a little bit more education. I particularly have a background in this because I've worked and lived tribal politics. But a lot of those are very interesting to reference here and give us a better understanding of how we're going to deal with autonomous agents moving forward in open source. So sovereignty. It's a supreme power, especially over a body politic. Freedom from external control or a controlling influence. It also implies a set of practices closely related to the production of knowledge about populations, territories, and resources. This is fascinating to me when we are dealing with this idea of open source and the idea of the commons. We always talk about the commons, but we don't talk about the feudal structure sitting on top of them and how we are recreating those digitally, for better and for worse. The development of sovereign political entities relies on that creation of bureaucratic and centralized administrations and tools whose vocation is to quantify and, by doing so, make a population legible and therefore governable. So who are we governing? A people considered as a collective unit. In open source, body politic is typically best partitioned not by sector, but by language. It is also very important to understand that packages themselves aren't necessarily tied directly to the corporations which may be sponsoring them. That maintainer or maintainers connected to that occasionally have full autonomy and may not have the same interest as a corporation. So sovereignty security requires really thinking about this differently. How are we going to begin behaving in a way where maintainers of projects with different backgrounds, different beliefs, and different priorities from your own can be respected? So we've got a couple of initiatives in security which are interesting. There's the OpenSSF, which I'm not going to speak a ton to because we've got people in the room who can speak much better to it. We've also got the Alpha Omega project, which is very interesting. So OpenSSF is a sub-foundation of the Linux Foundation intended to work on security. Within that, the Alpha Omega really, really fascinates me because Alpha and Omega, the intention of coming in and doing some quick interventions right now to security, but the long tail of Omega is securely integrating real technical solutions at scale. Really pay attention to the Omega of this. I find it really interesting. I'm not personally going to speak to it in this talk, but I hope that we cover some of that that's coming up and how you as an individual might be able to get involved. So some major blockers to secure open source from my perspective. One, we have to develop modern security education that globally scales. The major issue right now is just I literally can't hire anyone who has experience in supply chain security because it's too new. And we don't teach cybersecurity, modern cybersecurity, in any university well at this time. We don't really have that in place. Now, this is why I'd like to highlight the best SIG in OSSF, according to ourselves. That is the education SIG. We typically meet bi-monthly on Wednesdays. You can join that meeting anytime. We have just worked with the US government to attempt to provide an overview of how we can start educating for free on the open web to provide those real-time trainings to those who are either jumping into industry or want to improve their security in situ. Particularly, my focus in this space is on the third pillar, which is rewards and incentives for developers. Why? Because I care about maintainers, and that is a space where I can ensure that security is something that you get paid to work on because it is necessary that we start to put that in place. Number two, I think this is real and we need to talk about it. I'm concerned right now that OSSF is too cloud-centric. CNCF is not all of Linux Foundation, and unfortunately, as someone who is back to building supercomputers, cloud also runs on hardware. We need to be able to communicate those concerns about a full hardware, software security profile. And I really want that discussion to be had moving forward. Number three, runtime security. Runtime security is what I've been complaining about for years. It's a real increasing attack surface and likely requires a cross-foundation approach. My last statement on this is that within OSSF, there's the right education and understanding and incentives for security, but not for, runtime. If you want those, what you're going to need to do is jump to the AILF Foundation, because the developers working on sort of eBPF, observability of runtime, are sitting over there. We've got security conditions for runtime that we could execute from, but we need to do that in combination. I'd like to continue that idea. my wonderful second laptop has died. So my last note on this is that I really want us to think differently, because the last slide on here was not OSSF or any of that. It's the fact that we have an increasing number of globalized open source contributors coming into play right now. And if we do not build systems into place that respect cultural differences and sovereignty, we're just going to have a security wildfire that we cannot possibly put out. Every maintainer has the ability to be an autonomous agent within the basis of the license that they have put out. They've got their own rights and obligations, and we need to have structures that really work well for that worldview and that type of politic. I don't think we do yet. I will stop there because one of the last things that I think is very important is understanding languages, language ecosystems, and the idea of sunk cost. So it is true that the COP10 initiative, the attempt to keep green sort of carbon production below 2%, 49% of the total usage of the existing infrastructure for fossil fuels was implemented after COP10. Does that seem irrational or highly rational? It's highly rational because that infrastructure was very expensive and they want to make maximum gains out of that before they retire that. Why is that relevant to open source? Because there's a couple of languages that are highly valuable, used in corporate infrastructure, but aren't the best solution possible. Not for security and not for green production either. On that note, I would love to invite our next speaker, Rebecca Rumble, who is going to explain to you security in the language of Rust. Thank you so much.
Great. Good morning, everyone. Thanks for being here, and thank you to Amanda for giving me a platform today. I hope you've all enjoyed the conference as much as I have. So I'm not here to talk about math because I'm terrible at it. I'm here to talk about how foundations have a really critical role to play in making sure that we are securing our ecosystems. So I'm Beck Rumble. I'm the Executive Director and CEO of the Rust Foundation. For those of you that don't know who the Rust Foundation are, we are an open source language foundation supporting the Rust programming language. We're independent, we're non-profit, we're here to steward the language, making sure that the language and the ecosystem is well supported, that the maintainers are well supported, and that gaps are plugged, that everyone is well supported and able to do the best that they can do in terms of the work. We want to support and sustain Rust. We think Rust is awesome, and I imagine quite a few of you here will know quite a bit about Rust and how it's really sexy right now. Lots of people are really excited about Rust right now, which is exciting for us. We were in here yesterday and we were hearing from people at the White House going, you should totally use Rust. So we're riding a bit of a wave at the moment, which is great. We're very excited. But yeah, we want to do all the stuff to support the language. It's the maintainers themselves that actually they do all the really creative, really complicated work to develop the language. So in terms of security-wise, where we are, where open source is, we know open source is everywhere. in terms of in products, but in terms of geography as well. As Sal was saying earlier, there's no borders when it comes to open source. One of the things that we're kind of seeing is lots of different governments and different regulators talking about their approach, what they think they're going to do. And there's a little bit of fragmentation there that is a bit concerning. So we're not in a place where there's a unified idea of where we're going in terms of open source security in general. Security has been criminally neglected. It's not been an in vogue thing until very recently. It's been kind of seen as a bolt-on after the fact for years, you know. We'll do computer science, or we'll build a product, and then, you know, you're gonna buy something to bolt on the side of it that is security. It's not surprising that that doesn't work. It's not surprising that if you go back after you've built something and try and make it something that it wasn't in the first place, it's not gonna work that well. And again, echoing Sal's point, education in security has been really, really neglected as well. There are so many computer science courses that, you know, they might kind of touch on security for like half a module, but so many people come out of universities having studied computer science and really still don't know a lot of the basics. And still don't know how interesting and creative an area it can actually be to work in. There has been a lot of focused security work. We know this because some things are secure. But so much of it is going on inside big corporate institutions. And we just can't see that. You know, the nature of security work means that you can't really disclose it to everyone all the time. Because, you know, that would be foolish. But what we don't see a lot of the time is what really big things haven't come to pass because that security work has been done inside of a big tech company or inside of a different company. And the thing is that whilst that's good, a lot of the time that security work is protecting a lot of other people. It's shaped and directed by corporate interests, by business interests. And it's really difficult to know why some work is being focused in one area, but maybe not another. You don't even know if work's being focused in other areas. So we're not in a place where we even know, really, what security work is going on. And that's a problem. Because if we don't know where the gaps are, we don't know how to fill them. There's also this kind of widespread lack of coherent, coordinated investment that inevitably creates vulnerabilities. Because if you were going to look for those things, if you've got the time to go and look for those vulnerabilities, they are there because people are not working together. So we're not in the best place. But we're moving in the right direction, I think. You know, we hear a lot about current regulatory momentum, especially the US, the UK, the EU. This is kind of catalyzing change. You know, there's a sense that security is really interesting and it is really necessary and it's critical we actually do something about it now. So there is this great momentum that we can kind of take and move forward with. Unfortunately, there's not a lot of complete agreement on where we should be, where that final destination is. So these kinds of shifts in focus relate to regulation. Governments, as soon as governments get involved, you're talking about legislation, regulation. And I've put commercial products in brackets because, as many of you in this room know, when governments start writing legislation, regulation, these kinds of legal instruments, they're using terms like this that are a bit sticky when it comes to OSS. The Cyber Resilience Act in the EU, at the moment, there's a lot of people in OSS, myself included, that are a little bit concerned that the language used in that particular document doesn't actually reflect the reality of how OSS is. So there are contested terms that we need to make sure that we're pinning down in this kind of shift in focus so that regulation is actually appropriate. There's definitely an increase in focus, in investment from corporate bodies to support better security. So I have to applaud lots of the tech companies that are coming forward immediately and saying, yes, we totally want to put money into this. We can write you a check. Can someone spend it appropriately? We're very fortunate at the Rust Foundation to have a grant from the Alpha Omega program so that we can employ security engineers to work in our ecosystem. The establishment of OSPOs, this is great, and it's happening all the time. Every time I go to one of these events and I see a map of where the new OSPOs are, it's growing and growing and growing. So that's really good because we are having dedicated people that understand what we're talking about. If we're lobbying, if we're talking to government, they have a resource where someone knows what you're talking about when you're talking about supply chain security. And there's an increased understanding that security is linked to maintainer and contributor engagement, well-being, and compensation. That is so important. That's almost the last thing that people remember when they talk about security. You know, a lot of security that, oh, you know, the end user is going to be affected, normal people in the world are going to be affected, but actually investing in the maintainers, that's going to prevent so many things. So investing in our maintainers is kind of key to making sure that if we want to do anything really good with security, those people are kind of at the very front of that. So yeah, these are all good things. Regulation, I think, is a good thing. Increased investment, obviously, I think it's a good thing, but it has to be done right. Again, some of these things you all have heard from Sal earlier. You all have heard from other people at this conference. I don't think there's anything particularly controversial here. Why shouldn't we bake security awareness and development into computer science courses? It seems a no-brainer. We need to incentivize universities and professors to do that, though. You know, there shouldn't be hundreds of thousands of people coming out only ever having done C++ now. There should be a lot more Rust language, for instance, in these courses. But yeah, professors a lot of the time are incentivized by grants and other things in terms of developing their course materials. So we have to kind of figure out how we make sure we can get those people to bake these things in. Opt for more secure languages where appropriate. Again, another no-brainer. I'm not saying Rust is the answer to every problem, but it's the answer to some. And where it is most appropriate to use that, why not invest in that? Because that's investing in your future. There's an upstream versus downstream kind of debate. Whereabouts in the stream do you actually target security interventions or investment? Well, I think that along the whole stream, but definitely investing upstream is going to filter downstream. Obviously, we need to identify the key vulnerabilities and exploitable gaps and ensure that OSS ecosystems have neutral and sustainable security resources that are directed at the common good. So people to identify those gaps and vulnerabilities that are not working inside a closed organization where they are contractually not able to talk about what they're doing, but where they are working for the common good, and they are able to collaborate and talk to other people about what they're doing. And as ever, we need a critical mass of skilled and experienced people to do this. We can't just rely on one or two people. You know, people come and go. Investing in replenishing that maintainer resource is absolutely key, because we want to, again, spread the risk that something will happen and we don't have the right person to help solve it. So who should take responsibility for this? And obviously, I'm here as the Rust Foundation, so you know, I've got an agenda. Governments and regulators absolutely should not be the people that take ultimate responsibility for this. They can't, they shouldn't, and they won't anyway. They can't absorb this burden, but they are a key actor in helping to shape how the rest of us are able to respond. They have a really critical role in trying to shape and compel the key stakeholders to act in a certain way. Corporations are, again, absolutely key stakeholders in this. I would not expect any discussion on open source to exclude, or any solution to exclude the key corporate bodies. They, if nothing else, have a real responsibility to be funding a lot of this because they are the ones that benefit a lot of the time. But they shouldn't be the be-all and end-all. Too often, market forces are left to shape these spaces, and they inevitably leave gaps. We can't assume that every business decision about security made by a corporate body will also be for the common good. Individual maintainers should absolutely not be responsible or liable for this. And I'm probably preaching to the choir in this room, but this is actually a surprise to some people, especially if you're talking to regulatory agencies or people that don't really have a history of working with open source. There is an attitude that, oh, well, if you wrote it, then it's your problem. You should be responsible for it. And unfortunately, that's a demonstration of how little an awful lot of people that touch on this know about how open source works. Individual maintainers should absolutely not shoulder this burden. And we cannot expect them to mobilize quickly or coherently or whatever if there is an issue. There needs to be a certain level of support and protection for maintainers because security so often is absolutely not their fault. So everyone here has a role. All of these people are stakeholders, but the current situation demonstrates that this model creates huge gaps. So my colleague Paul likes to say that OSS is a bit like building and painting a house. You get lots of individuals turn up, each with different interests and different skills, and the kind of goal is to build and paint a house. But you've got some people that are really, really interested in intricate details, so they only really want to do the windowsills. You've got people that like working with gloss paint, so they want to do the front door. I turn up, and I only want to do the bit of the wall that's in the sunshine because I like it warm. You've got a guy that's going to do the locks, but he can only come between 2 a.m. and 5 a.m. when no one else is around. So you think he might have turned up and done something with the locks, but you're not really sure because he didn't leave a key. What you end up is you have something that's like a house, and it works okay, but it's not really right. There's bits that are left unpainted because no one was tall enough to get up there, or no one had a ladder. I could go on. But what I'm saying is the current approach means that there are gaps because whether people are turning up voluntarily just because they're interested or their companies told them to turn up and do that bit over there because that bit's important to them, there are gaps and there are things that don't work or don't work together because there hasn't been a coherent plan and no one is stepping up to say, oh, well, that support beam in the middle actually is really important, so why don't we all pitch in and fund that bit? We're left with gaps currently. So I think this is where I give my proper pitch as the Rust Foundation. I think we as the Rust Foundation and other foundations in the space have just this really critical role to play here because we have no other interests apart from making sure the language and the maintainers and the people that use the language are happy and well supported and it works. If Rust programming language starts becoming the language people go, oh, I wouldn't actually touch that because it's too buggy or it doesn't have the right functionality or whatever, there's a problem there. We don't want that. We want people to love Rust and we want people to use it. And we're non-profit. That's our only reason for existence. We're not here for developing money other than to spend on the Rust programming language. We're not political. We operate across borders. So we're not beholden to the US government, the EU, the UK. We have to consider everyone that's in our global community. So while we do have to abide by regulations and we do have to consider what the legal frameworks are in the company in the countries that we operate in and we're registered in, we have no political interest beyond ensuring that we and our maintainers can continue to do their work. We work really closely with the communities. We're here for them. We also work really closely with corporate stakeholders because they support us through membership and through grants and other work. So we have really good relationships with those two very different stakeholders. We're able to create a bridge or to facilitate collaboration between those two worlds. We also have expertise in policy. We're used to talking to governments. We're used to lobbying and saying, actually, this legislation you're developing, that's not going to work. Or this will have unintended consequences that will hurt and hinder what we're all trying to do here. So we have that ability to talk to governments as well and try and ensure that we can influence things to the benefit of our communities. We speak to academics. Lots and lots of people want to develop Rust, for instance, into their syllabus. And we try and make sure that some of those materials can be shared, that they are as open source as the language. And we work with think tanks as well, who are kind of also operating in this space and thinking kind of outside the box of other kinds of solutions and places where open source can be useful. So we have this really rich tapestry of relationships that we're able to call on, and we're able to kind of facilitate things in a neutral space where, again, we're all kind of there for one neutral benefit rather than for a specific corporate interest. We have infrastructure, which is really boring to most people. But we have people that love spreadsheets and love to do finances, and we are able to facilitate larger projects that are simply unrealistic between individual maintainers and large companies, for instance. We're able to be a go-between there. We're able to kind of say, okay, we will do X with a very large amount of money, and we can kind of act as that go-between, so we're not placing a burden on maintainers to say, you have to be accountable for every hour you spend on this particular piece of work. We can kind of collate and do all of that heavy lifting so that they don't have to. And we've got a good understanding of where gaps are. You know, we talk to the maintainers all the time. We talk to stakeholders in the corporate and government world all the time. So we're constantly kind of having information given to us that says, you need to work on X or Y, or this is going to be a problem in 2 or 3 years' time, whatever. So we have this really kind of unique role where we're kind of a meeting place and we're kind of an information sharing service and we're kind of a finance service. But we were able to do this in a neutral way where there are very few other places that you can do that. So in terms of security specifically, you know, I think we're amongst the best place. Again, obviously I'm going to say that. I want you all to write me a big check so I can spend it on security. But foundations, we are definitely among the best placed organizations. And I'm not just saying the Rust Foundation, there are lots and lots of open source foundations that are doing the same kind of excellent work. And with sufficient support, we can make a real impact. You know, we can do really good, coherent, impactful work. You know, we can facilitate collaboration. We can develop educational materials. We can employ dedicated staff to work on this in the open. You know, not behind closed doors and not for a certain particular business interest. We can hire staff to actually work in the open with our maintainer communities, with our stakeholders, and for the common good. We can also work with policymakers, with governments, regulators, as I said, and lobby to ensure that that regulation is appropriate for our needs. And we can support innovation and agility. You know, we're pretty agile. We're not like a huge corporate behemoth. We don't have really lengthy recruitment practices. We try and be as agile as possible, and we try to be able to pivot to whatever we need to do at that time. But all of this needs to be well supported. It needs to be funded. We can't do it on the shoestring that generally we operate on. The key to enabling good security work that can be directed like this, that is in the open, it's to develop a sustainable funding model. And I mean sustainable. At the moment, foundations like ours are generally funded on a kind of yearly basis. We don't know from one year to the next what our budget's going to be. You know, at the moment, obviously this year, we're not in a bad position right now, but you know, the tech slowdown, we have no idea how that will affect us in the future. It may be that our membership reduces. And what do we do then? There's a huge hole in our budget. We get grants. You know, as I've said, it's been amazing to have finances given to us to support our security work, but that's for a year. I can't fix security in a year. It would be great if we could, but yeah, security is kind of an ongoing thing. You know, we need to kind of continue funding a security engineer to work in the ecosystem. But if you're a security engineer, which is kind of niche at the moment, you're very in demand. You've got a very, you know, in-demand skill set, and we're only able to offer you a one-year contract. Whereas if you go and work for one of the big tech organizations, you've probably got a lot more job security, and you're probably going to get paid twice as much. So there's this kind of issue here where not only are we not able to provide job security, an attractive place to work for security engineers, we're actually competing financially with the very stakeholders in this that are giving us money to do this. It's a bit daft. So yeah, we need something a lot more sustainable. I am much more likely to attract really, really good candidates if I can say it's going to be a 3-year contract. One-year, sub-1-year contracts, it's very, very difficult to attract the right staff. SME tech. Do you know, some small organizations are amazing. They're so supportive. And they want nothing in return. So many are just so enthusiastic about the language, they just want to support us. But for every one like that, for every one small organization like that, there are like 50 or 100 that are benefiting and giving nothing back. And this is becoming increasingly unacceptable. You know, it's really, if we all want a secure place to live and work and play online, we should all be contributing to it. And governments should contribute. We kind of forget this. Governments use so much open source. I think the problem is half the time they don't know it, or most of them don't know it, but they do. And they should be leading the way. They should be setting a real example to everyone else that if you are using open source in your day-to-day, then you should be paying for it. Most importantly, though, they should be ensuring that there is a mechanism built into any regulation about security. There has to be a way that it's non-optional, because if it's optional, people will opt out. There really, really needs to be something there that says, okay, if you're using open source in your product, then, I don't know, you have to pay something to this central agency that will distribute it to open source foundations, and they can actually sustain the work that they need to do that will benefit everyone. So that's my 2 cents. Thank you very much for listening. I'm here for the rest of the day. If anyone wants to come and talk to us, we've got a table on the first floor. But yeah, just to say, I think I'm really enthusiastic and I'm really optimistic that we're going in the right direction. And I think if we're all kind of on the same page and we're all kind of pushing in the same direction, that we will see massive improvement and massive impact. So yeah, thank you very much.
We've got about 5 minutes before we start with confidential computing at 11:10. All right, welcome back to the security track. I would like to welcome Mike to the stage to talk to us about confidential computing. Welcome in.
Thank you very much. Thank you, everybody. Maybe we'll get a few more people in. They've probably just gone for a quick break. Welcome back, or welcome to the most interesting, cool, and let's face it, sexiest track at State of Open Con23. So my name is Mike Bursell, and I'll get on to what I do a bit later on. But I'm here to talk to you about confidential computing. So let's first start off with understanding what the problem that we're trying to solve here and what's the issue that is at stake. But we'll start off with a story because I like stories, and I think stories are always good, and we don't always use enough of them in security. So let's start with a story. Once upon a time, computing was simple and computing was safe. And it was mainly run by people like this, mainly actually run by women making things just work. And you didn't need to worry about security particularly. Unless, of course, you were trying to do cryptanalysis on a foreign power. But that's a kind of different type of security, right? Then along came the Brits, who messed it up royally. What do? Well, it comes down to tea and cake. So the older among you may just about remember Lyons tea shops. Does anyone remember Lyons tea shops? It's just me, isn't it? They were everywhere. They're in all towns all across the UK, and they did tea and they did cake as well, which is good. And you could go along, and it's kind of like Costa, but really not. But kind of think that, right? Costa, Starbucks, whatever. But they were so big that they needed to think about how they managed their distribution. And some bright spark thought, these computer things, couldn't we use them? And said, oh, God, let's give it a go. And, they had a couple of spare rooms and, lots of heating they didn't know what to do with. So they created what's called Leo 3. Obviously, Leo 3 is the third one. This isn't a pope. This is Leo 3, the computer, okay? And this is a picture of, I think, the data entry of Leo. They obviously had the men in the foreground and the women in the background because it's safest that way, But this is what it looked like. And the evil geniuses who were working on Leo came up with a clever idea, which is called multitasking. Okay? Now, multitasking sounds like a great thing because it means that if you're not using all of your compute power all the time, someone else can use it, or a different batch job or whatever could be using it at the same time. And ever since, in computing, people have been obsessed with sharing. This is not a good thing. Not only for computer security, but also for cake. I'm not a big fan of sharing cake, as some of you may have realized, but it creates all sorts of problems. So let's talk about why it creates problems, okay? The problem is basically computers. Because, well, it's not really, it's kind of actually the workloads rather than computers, it's how they work. So I'm going to move us forward a few decades now, not quite centuries, a few decades, to talk about standard virtualization. So I kind of assume that most people here have heard of virtual machines, have heard of containers, have heard of all those sorts of things, right? So the way that they work is you've got these kind of workload things, applications, whatever it may be, running on a host operating system in some hardware. That's kind of computing, right? And the problem is that these workloads may be from different users, or one of them might get compromised, or completely different tenants. And you want to worry about how you isolate these workloads which are running at the same time from each other. And one way of thinking about isolation is called the CIA triad. I can say those three letters here because I'm talking about confidentiality, integrity, and availability. Okay? So confidentiality is stopping one workload looking into another workload, right? That seems like a good thing. Integrity is about one workload stopping the other workload, basically being able to mess with the bits and the bytes and change the data or even the program inside another workload. Availability is making sure that one workload can't stop the general working of the networking or the storage or just the general CPU usage of another workload. And generally availability, you can tell if your workload is not doing anything, it's not responding, it's not too difficult, which is a great start. So we're kind of going to worry mainly here about the other two. So there's 3 types of isolation for workloads. One is workload from workload isolation, right? This is what I talked about just now, and that is stopping one workload looking into or messing with another workload. And it turns out that we're quite good at this. It's not so hard. We've had 20, 30 years of work, or maybe more, depending on how you look at these things, of working out how to stop these things. And VMs, containers, do this pretty well. The second is actually when you start talking about the host, because you want to stop your workload from messing with the host. Because if this workload can mess with the host and change what the host is doing, then they can do it whatever they want to the host or, in fact, to any other workloads, right? And it turns out, again, that VMs and containers are pretty good at this. Hypervisors, all those bits and pieces, right? VTX extensions, blah, 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 and all the nice things that containers do with groups. There is a third type, and that is workload from host isolation. This is where things kind of get interesting and worrying. And the problem is basically that the model we started off the world was that whoever owned the hardware was the person who's going to be running the applications. But if you're putting stuff in the cloud, then the person who's actually running the application is someone completely different. It's not Amazon or Microsoft or IBM or Oracle or whoever it is who's actually running the applications. It's their tenants, it's their customers, right? And the problem is that classical virtualization techniques can't deal with this problem. They're not designed to. The way they work is basically they expect to be able to look into the memory pages on the machine and do anything what they want with them, which means that if you own the host, you own the workload. And by own, I mean own with an O or with a P. So if you compromised it, it works either way around. So let's talk specifically about the edge. So this is obviously a little bit awkward, right? Because if you can't be sure you entirely trust your cloud or your edge provider, it's going to be good. But of course it's okay. Of course it's okay if you trust your CSP and all of their sysadmins and all of the hardware, software, and the firmware stack from compromise of the supply chain or at runtime now and in the future. And if your entire CFO and board and the auditor and the regulator do as well. And if you're running sensitive data or have customer information or you've got sensitive algorithms or you work in finance or defense or healthcare or pharma or you have cryptographic keys or any of these things, you need to start worrying about this sort of thing. And the regulators are worrying about this sort of thing. Not all clouds are good, sorry. So, we've got a problem. How do we address it? So, there is something called confidential computing. And this is a definition from the Confidential Computing Consortium, which is of whom we have our beloved leader, Steve Wally, actually here in the audience today. And confidential computing is the protection of data in use, so not just in transport or in storage, rest, by performing computation in a tested, hardware-based, trusted execution environment. Lots of words there. The key thing to be aware of to start with is it's hardware-based. So it is hardware, CPUs, which are providing you with the protection. And we'll come back to that in a bit. So the CCC, Confidential Computing Consortium, not the Chaos Computing Club, is a Linux Foundation project. It's focused on open source software, as it should be, and it has broad industry adoption. There are lots of big names there of whom you will have heard, as well as lots of startups as well who are involved with it. And it kind of looks at the world a bit like this, right? If you think about privacy-preserving computation, or something called PETs, privacy-enhancing technologies, trusted execution environments sort of sit here, and confidential computing is hardware-based trusted execution environments for full general compute. So things like TPMs don't count because you can't write a general application and run it in a TE, right? You can't write something in Rust or C or whatever and run it in a TPM. Whereas you can using these technologies. So the technologies which are best known, Intel's SGX, AMD's SEV SNP, ARM's CCA Realms, coming out in ARM 9 about now. Intel recently announced TDX, and absolutely not AWS Nitro. AWS Nitro does not meet the definition of confidential computing as per the Confidential Computing Consortium, because it's not protected all the way down to the hardware. I'm not going to go on about that, but it just doesn't. So let's talk about how it does this, okay? So it uses what are called trusted execution environments. And they're based in the CPUs. And what they do is they encrypt workloads. Specifically, they encrypt the RAM, the memory pages of workloads. And each workload has a different cryptographic key, which is kept in the CPU. And that data page is only ever, memory page is only ever decrypted when it's actually in the CPU. And it's then re-encrypted immediately before going out on, into general RAM. And so they can protect integrity and confidentiality, but they can't really protect availability, because if you have control of the CPU or something like the operating system, you can stop applications having access to CPU resources, networking resources, whatever. Not much you can do about that. So confidential computing is about deploying applications, workloads to TEs, to trusted execution environments, which is harder than you might think. But first, is it really T? Remember I started off with a T metaphor? I'm going to go back there because I'm a Brit and I'm actually giving this in the UK for a change. I don't often get a chance, so I'm going to go with it. Just stick with it. It's cool. There'll be cake too. So here is a scenario. Like, let's pretend, and you don't need to pretend very hard, that I love tea and cake. Okay? So let's say I've got some cake and I want to eat it with some tea. I call your cafe and to order a pot of tea, okay? And you'll provide the pot of tea, and I'll come with the cake, but before I turn up, I can't check whether you've provided me with real tea. And by real tea, I mean proper tea, not any of your herbal rubbish, okay? I mean proper tea, Assam, something like that, okay? Earl Grey, okay, not really my thing. Ceylon, anyway, that's what I'm looking for. What if you do the very worst thing, which is provide a pot of coffee instead of tea? How am I supposed to know what to do? So, what I need is a remote, trusted tea taster who can warn me before I turn up with my cake, which is the application, the workload, in case you haven't got there yet, right? Whether I should turn up or not. So this is it. So either my trusted tea tester, she will say, that's a lovely tea, or she'll say, no, no, don't, whatever you do, turn up. Okay. So here, to sort of pull the analogy together a bit, and I mean a bit, I know I'm pushing it, the CSP's machine is basically the cafe that I'm going to. The T is a trusted execution environment. I'm really sorry about that. The coffee would be a spoofed tea. Right? So someone pretending, the CSP saying, of course I provide you with a real tea, you can trust it, it'll be fine, but actually they haven't. And the cake is my workload and the data. Yeah. So attestation, and we saw in that definition, it said an attested hardware environment. I didn't push it, but this is the important thing, really, really important. Attestation is the measurement of the T instance by a trusted entity and the subsequent verification of it, okay? So either valid, it's okay to send your application, or it's a spoof, don't deploy it. So the question is, how do you find a trusted entity in the CSP, which owns everything, including the hardware, and the software, and the OS, et cetera, et cetera? It's really difficult. But the CPUs we're using thought of this or the creators did, and they created the capability for CPUs to do the measurement and to sign the measurement cryptographically, so you've got something to check. Okay? So they'll sign the TE and its memory pages, which means that you've got a chance of checking what's going on. So actually, and this is where it gets we have to break the analogy bit. The measurement is on the host cafe, but the validation must be managed by a trusted entity who is not owned, not controlled by the CSP, an attestation service. Okay? And so we've got two very trustworthy looking people. I know they're trustworthy because they're wearing white lab coats, and they've got a thing of blue liquid, so they can certainly be trusted. And they will tell me whether or not it's okay. And if it is, I'll bring the cakes. Now, the problem is this is very, very difficult to get right because attestation is very complex. And of course, all of the providers of the CPUs provide completely different ways of doing it. Why wouldn't they? But also, it's devastating if you do it wrong, because if you think you've got a good measurement, but you haven't, you've just given away everything that you're trying to protect in the first place. So enough with the tea and cake. Let's talk about an attestation process. This is the safest way of doing it. There are other ways. This is the safest way. So let's say the green box is a trusted execution environment that I want to set up and I want to deploy something to. We've got a CPU, and off the box, off the CSP, we've got an attestation service, and we've got a user who's looking very chipper this morning. I don't know. She probably had some very nice tea. So the TE creates itself, or is created, and we say, please measure it. And the CPU does measure it. You can tell it's a measurement because it's in zeros and ones. Obviously, low-level stuff, so it must be zeros and ones. Binary, ladies and gentlemen. And it signs it. It's got a little padlock again. It must be nice and safe. And it sends that to the attestation services, which are the nice people in the white coats with the blue liquid. Now, if that is good, it's checked it, it knows it's got a list of known good measurements, it will then say to the user, it's fine, you can deploy your application. You deploy it, you run, you're happy. Now, of course, it is possible to deploy the application first, but if you do that and it's spoofed and there's anything sensitive in your application, you've just lost that as well. So this is the safer way of doing it. OK, so we'll just wrap up, because I want to leave a little bit of time for some questions. Who needs confidential computing? It's everyone, OK? Just so I don't want too much peril and excitement in this. Healthcare, finance, pharma, defense, all of those people, they need it, because they deal with sensitive data, they deal with customer data, they deal with citizens' data, et cetera, et cetera. In fact, anyone with sensitive data or sensitive algorithms. Because if you are running on a complex risk analysis process for a bank, that's often worth more than the actual data you're taking in the first place. So you want to be protecting that. So it might be in the public cloud, or it might be in the edge, or even in your private cloud if you're worried about insider threats. So, yep, everyone needs it. So I'm sure you have nice parrots like that in Brazil, don't you? Yes, you do. OK, fine. We've got Nick from Brazil. He's approved this slide. So very quickly, why open source? You may have noticed we're at a big open source conference. Well, the first thing is it's visible. You need to know what you're running. Because if you're going to trust your crown jewels, your most sensitive data and applications to the cloud or to a project, you want it to be open source. You want it to be auditable. And our view is that everything should be open source. It should be the meetings, the chat, and just a slight plug here. NARCS is an open source project, part of the Confidential Computer Consortium. Nick's wearing a T-shirt. You can have a look at it, have a play with it. Design process, everything we think should be open source. Because if it's not open source, you can have no technical assurances in the code, nor any basis to trust any system using it. If you're interested in trust, I have a book out, obviously plugging it, but yeah, search my name, you'll find it. So this is it. This is the talk. I am Mike Bursell. I was, until 5 p.m. on Monday, the CEO of Profion, a confidential computing consortium startup. I made myself redundant on Monday because people don't get it yet. We're about 12 months off for the sort of adoption we need. So we had to close down the company very sadly. If you're looking to hire people who know about this sort of stuff, I'm looking, as are all of my staff. But this is really cool, really interesting stuff, and you should get involved. Love to talk to you about it. Contact me on LinkedIn. We've got 9 minutes for questions. Gentleman over there with a question. He has a mic.
Thank you. That was a really interesting talk. It's an area I don't know much about. I've got a silly question and a sensible one. Do you want the silly one first?
I'm going to say there are no silly questions. There are silly questions. Give me that one first.
Okay. Why did your tea taster have a coffee cup in front of her? She's dodgy.
Because you can't be sure.
Yeah. Get yourself a better tea tester. I'm still trying to wrap my head around when and where you might start using this, because if I was concerned about the integrity of the CPU that I was running on, I'd also be concerned about the integrity of my database, the data in transit to move to the cloud. I guess being a pragmatist at the moment, I might be incentivized to keep that data closer to the business, either in a data center or the old-fashioned server room inside your own premises.
Yeah. And that's what
would you say to people who are considering that?
I think the problem is mainly in the other direction. People are moving stuff out without realizing the dangers of it to the cloud and to the edge. That's changing. When it comes down to it, you have to trust something. You have to have, in fact, there's 3 things you need to trust in the model I've talked about. One is you have to trust the CPU, and that it's come from, let's say, Intel or AMD or ARM. And you have to, you need to trust them, but you need to trust that it's come from them. So trusting that it's come from them is dealt with by the certificate chain when you do the measurement, okay? You then have to trust them, and when it comes down to it, something's going to be running your code anyway, right? So that's it. You have to. The second thing you need to trust in this model is our code, which is basically the runtime which runs inside it and makes it all happen and does the attestation. Okay? The third thing is your application. You wrote it or you bought it, you kind of got to trust it. Nothing else should you need to trust. The host OS, the hypervisor, the admin, any libraries, any of that stuff, any other workloads. So
what about the storage, though? Most enterprise
okay,
applications
so
have a big
the answer
database.
to that is you should make sure that anything that comes out of there is encrypted. And the NRX approach, transparency encrypts all network traffic. Storage isn't supported yet, but absolutely you have to do that as well. You should always do that all the time.
So the general principle is that when the data comes into the CPU, that's probably the only place where it has to be unencrypted to perform the work.
Yeah.
Now I get it. Thank you.
We have another question. Thank you. Good questions.
What's the performance overhead from the encrypting the memory page?
Yeah, sure. So not so bad. It depends enormously on a couple of factors, really. Well, 3. One is the architecture. So Intel SGX versus Intel TDX, which is coming, versus AMD. Generally, for most workloads, you're probably talking single-figure percentage points, maybe low double figure from that. Another thing is you've got a runtime in that's going to be running things, right? Typically, that'll add something. The NRX project uses WebAssembly, which is heavily jittered and improving nicely. So again, you're not talking more than a few percentage points. There's also the case that you can write pathological applications, which are going to make this very bad, because for instance, typically you're going to do a lot of entering and exiting, and that's very expensive because you've got a lot of syscalls and all the context switching, basically. So you can write pathological ones, but on the whole, it's considered worth it, I think. We have, I think, 2 more questions, one at the front. And
I borrowed the microphone, sorry.
No?
Is the enclave, is it big enough to fit the entire VM in, or do you have to simply keep some of your data inside the VM, inside the enclave?
Okay, so this is not a VM play, okay? So the way that the way that some of the chips implement it is by doing a VM. But by a VM, all we mean is a vCPU and some memory pages. Now, if you want to load an entire Linux virtual machine in there, knock yourself out and deal with a TCB yourself. That's not the approach the NARC's project takes. For instance, provide a WebAssembly runtime which is under 15 meg. Okay, so you don't be. But the answer is yes, you can scale up to gigabytes with some of these technologies now. Any other? I think you had a question, did you? Yeah. Yes. Sorry. And please find me afterwards and do the LinkedIn thing. Mike Bursell, you'll find me. There's only not very many of us.
Is it possible to, so I'm quite interested in the idea of like compute over data, so sending the algorithm to the data. Is there a way to do that in like a trusted way? So for example, if you want to run compute on multiple different confidential computing servers that hold health data and then aggregate those results into a larger sort of...
Yeah, sure. So, I mean, there are companies, startups and larger companies, who are creating frameworks that do that to allow you to do that. Or you can just run a standard, the TEs are very well suited to microservices. So if you have a microservice-based architecture, just design a microservices architecture and move things around as you otherwise would. As we already said, you should be encrypting stuff between them anyway. And if you, again, the way that NARCS does it, you have a certificate which is based in a particular application instance, and you can use that to help yourself out. But yes, absolutely you can. You don't need to put it all in one place. You can use this stuff for generalized compute. Write your current microservices. As I said, NARCS uses WebAssembly, so you can write stuff in Rust, C, C++, Java, Python, Go, compile it to WebAssembly, and then just run it as you'd expect. I think we've got one here first, and then you. We've got a couple more minutes, and then I will be around for a while. Please do find me. And anyone online, waving at the camera, Mike Bursell on LinkedIn. Look, the cameraman's waving back. Oh, that's really sweet. Please do that.
Thank you, Mike. You said that people aren't ready yet for that.
People aren't ready.
People are not ready yet, right, on the adoption side. So how do you foresee adoption happening? Who needs to trigger whom for this thing to fly, basically?
There are a number of steps. One is the availability of the chips. They're becoming widely available now in the cloud. And so you can go to AWS now, you can go to Azure now, Google is a little way behind, Equinix, bunch of people. You can buy the stuff, you can buy these chips off the shelf. It's just standard EPIC chips and whichever and Xeon chips. So that's one. Secondly, there needs to be a number of ways to make it easy to use this stuff. As I said, it's quite complex. You don't want to just be taking a couple of memory pages and a vCPU and doing all the stuff yourself. So there needs to be projects, hopefully open source projects, and more of the projects are going open source, I'm pleased to say. More of the products are going open source to support this. The regulators are beginning to pay attention, but regulators can't say anything until there's commercial availability, because otherwise the industry will just push back. But they are beginning to pay attention, and not recession, because it's very difficult to convince people to do new stuff when they're trying to keep their existing businesses going and keep their existing staff, frankly. So that's where we had problems, frankly. One more, I think. Oh, two more. See if we can get through them.
Maybe I have time for one.
Is there any possibility of making it work with accelerators? Or like GPU compute?
That's a lovely question. So the answer is yes. OK, a bit more than that. So the GPUs are coming. We know there have been some announcements. We expect to see DPUs and stuff as well. The problem ends up being not so much putting stuff on them as creating the trust relationships between the different parties. So there's work going on in the PCIe, I think IEEE, working group at the moment on how that sort of stuff happens. Really interesting, difficult stuff. So the answer is yes, we expect it to come. Try a quick one, if we can, with this gentleman here.
Yeah, so quick one. Is that a theoretical scenario or is a real threat? I mean, is there any real attack happening on that area? Because maybe what you need to get more attention is a real attack, a real exploit, that will make the news, for example?
Yeah, the problem is that most of the breaches we've seen over the past 5 years would have been significantly mitigated if this had been in place. That's not enough. It's not enough. People are just finding other ways around it, or keeping stuff in-house, or just keeping stum, keeping quiet. So that's why the regulators need to step in. Right, thank you very much indeed for your time and attention, ladies and gentlemen, boys and girls, and everyone online as well. Do get in touch. I'll be around for questions. Thank you.
All right, trying to stay on time with the security schedule. We've got 5 minutes, so come back at 11:45 and you will learn more about OpenCRE. All right, welcome back to the security track. I would like to bring onto stage Spiros, who's going to be talking about OpenCRE, a cloud of knowledge, with a very cool demo. Welcome on stage.
Hello, everybody. How has the conference been so far? I have really enjoyed it. As I said, OpenCRE, cloud of knowledge. Let's find out what this is. OK, it's working there, but not there. Few things first, get them out of the way. My name is Spiros Gasteratos. I am a security engineer. I've been participating in OWASP for 12, 13 years now. I'm an open source developer. I love open source. I've been doing it since before I was participating in OWASP. My current employer is Control Plane. I work with them. And you can find me at InfoSec Exchange. It's 0xFT and the Bird site, if we still call it that. So OpenCRE, super important, is an interactive linking platform for security standards and guidelines, and it's maintained by a gentleman called Rob van der Veer, a security veteran, and myself. OpenCRE is initials in security. I think we love our TLAs. It stands for Open Common Requirements Enumeration, and it's basically a gigantic index or a graph, if you will, or where we link together different sections and subsections from different standards. We currently support many standards, such as OWASP ASVS, NIST 63, 53, proactive controls, OWASP cheat sheets, the Web Security Testing Guide, the CWE enumeration, KPEC, and we keep adding more as we keep getting time to do this. It was made by myself, Rob van der Veer, Elisad, many friends in the industry like OpenSSF, the OWASP Top 10, and the Secure Knowledge Framework. But you might wonder why would anyone in their sane mind embark on such a journey? Well, first, we're not exactly sane. Second, because of that. What you see in front of you is the European Cybersecurity Organization study on how many security standards there are. It's practically a list of existing security standards. Its length is about 200 pages, and it's just a list of names, not of content. This is not really great. It makes it very hard for us as standards consumers and for standard makers to find any relevant security information and also to keep information up to date. It also causes a lot of duplication of work and, and also it is redundant. And we don't need to be doing that. All these standards talk about pretty much the same things. So let me demonstrate a little bit why this is such a bad thing. Say that anyone here, as a standards maker or like an internal company wiki, security wiki maintainer, needs to write anything about security requirements. For example, secrets management. And you write anything you need your developers or your coworkers to do related to secrets management. And at the end, the way we currently do it is we add a bunch of references to a bunch of things that we believe have extra value or added value. For example, in this one, perhaps you think that the OWASP Top 10 on sensitive data exposure is relevant, 2 CWEs, proactive controls entry, and 3 other random standards. This, in theory, is fine. What immediately happens is nobody understands why sensitive data exposure is there, so nobody will click it. CWE has deprecated in the week between your developers reading your documentation and you writing it, has deprecated 1 to 3, and 4, 5, 6 is maybe has changed location or changed meaning. And proactive controls, it is proactive controls C6, unless you know proactive controls by heart. No developer is going to know what this means. And maybe other standards have migrated to a new version, maybe some resources are missing, or maybe standards disappeared because bus factor or the community disappeared. It happens. But then your consumers end up with irrelevant information or information that is hard to find and digest. So what do you do? And here's what I used to do. I would think that I'm very smart and go to the original resources, copy-paste everything that I found relevant, and add it to my documentation, which would create bloat, would create super long documentation that is very hard for me to maintain. And because I'm not a master of every part of cybersecurity, despite what I try to tell people, all my documents would be either outdated, incomplete, or because I'm not an expert, it would be inconsistent because I copied for 2 different resources that I didn't quite understand. So in CRE, we have managed to kind of solve that, and I'm going to show you this via an early demo. If I could have this on the screen, thank you very much. Here's a standard. This is a NoWasp cheat sheet related to secrets management. Normally, this specific resource would suffer from a very, very long list of random links at the bottom. And not just one screen, but maybe 5. What they've done is they've added a link to OpenCRE, which has taken them, which takes the readers to this fantastic page that has a bunch of links to explore more information. But then the reader can choose and filter which information they want is relevant to them, and this information is presented in a way that makes sense for either technical audiences or high-level consumers. For example, if you are a developer, you might need to look at the OWASP Secrets project, which shows you how not to do secrets. Furthermore, if you are a higher-level director or an auditor and you don't care about the nitty-gritty technical details, you might want to look at the higher-level standards like secure data storage, or if you care about cloud, you might want to look at the cloud controls metrics. And this is, let's go back. And this is not, CRE is not just to be consumed via the outside. CRE is also extremely searchable, and you can find a lot of information on several topics just by adding keywords. For example, I type session. Here's everything we know about session with CAPEX, NISTs, and even tooling rules. For example, ZAP, that's a recent experiment. And here's everything internal we have on session, which links you to ASVS, WSDG, cheat sheets, etc. And as always, NIST, because they are a very complete standard. But this is not all. Standards are not only meant for human consumption. And this is a big mistake we've been doing so far. We've been writing pages and pages and books on what we should be doing, without ever stopping to consider what are we currently doing, and is any of this relevant? So CRE currently supports export formats in multiple ways that are machine parsable. Here's all of CAPEC in JSON. You can download it, get our ISO JSON, and find if there have any 2 CREs in common, also known as gap analysis sometimes. Here's ISO in Markdown, just in case you want a link to ISO and to other standards, to other CREs that ISO links to in Markdown format, so that you can readily copy-paste things to your internal wiki. And because OSCAL these days is a cool new standard, a cool new way to map things, here's all of OWASP ASVS, one of the main standards from OWASP, in OSCAL format, which, again, you can feed into your tooling and find more information about the controls or the tooling that satisfies a specific control. And this is it for demo, kind of 4 demos into one. If we can go back to the presentation. Does this work? Oh, cool. So you might wonder, how did we get here? Because this structure, CRE is a 3-4-year-old project, and this structure doesn't happen from day one, and it was a hard road. We started, as with everyone, with a spreadsheet. Spreadsheets make the world go round, and this country knows a lot about spreadsheets, if I remember the news correctly. So we started with OWASP, 2 projects from OWASP, ASVS and the testing guide, and KPEC. And we thought, why don't we find out how are they related to KPEC? So we started drawing lines and on a spreadsheet and putting things in pivot tables and doing like Excel mastery or magic, I guess. And that very quickly grew in a quadratic way, and it became unworkable. The second we started adding NIST, which is a chunky standard, it completely overwhelmed us. There was no way we could map anything more without, well, losing sleep. And I like sleeping. So what did we do? As I said, most human standards speak about the same concepts. And because they speak of the same concepts, well, you can extract the concepts, find what each part says, and link to it. So now you have, if we talk a little bit about data structures, you have a star, which is a concept. The center of the star is the concept, and then it has edges that link to a standard. This is fantastic, and you can have as many stars as you want, and you can be as high level or as technical as you need to be. Solved, right? Like we can all go home, security solved forever, there is nothing else to do. Then we tried to map NIST. And NIST has some very high level concepts such as cryptography. And cryptography is, let's say, interesting to map in a technical aspect because it has a lot of knowledge that needs to be disseminated. So the second we tried to map cryptography and how to store secrets, we needed to add 36 CREs to attach to it. And there was no way we would ever go to NIST and tell them, here's 36 CREs that you need to attach to every single NIST, and you need to do this for all your standard. They would tell us, get out of here, here's the door, here's a boot, and bye. Which, I mean, they would be right? So we thought, hey, we know data structures, so let's create a tree. Let's create higher level topics for CRE that link to or group together lower level topics. Now our data structure is a tree. Trees are nice, we like trees, and it allows mapping of any level of technicality of information. Fantastic. Next problem. Standards change. I said that a few slides ago, right? Standards change, and they change surprisingly fast, especially if you care about open source standards and not government-owned ones only, and if you care about staying up to date and being right. So we did a lot of effort to map OWASP MASVS, and literally the next day they released the next version, because we never thought about asking them, as you do. So we didn't want to do that again, so what did we do? We created parsers. Luckily, we know how to write Python. So we created parsers that allow standards to embed CRE links into their text, and we can parse those text and map automatically. That gave us a byproduct, which is great, of allowing CRE to be automagically updated, automagically new word, perfect for this. And because it's automatically kept up to date, always as the standards evolve, we are here now, which we enable alignment and cross-reference between security standards and guidelines. As you saw in my examples, we do not only map standards, we map guidelines as well and technical documentation. It is easier for standard makers to create and maintain standards. You do not need to create and maintain the mappings yourself anymore. It is easier for us end users to find and use relevant information. If you're an engineer, you do not need, and your auditor tells you, are we compliant to NIST, or you need to comply to PCI, you do not need to know what PCI is. You just click on PCI, go to CRE, and find the relevant OWASP cheat sheet. If you're a security officer, you do not need to know what a cheat sheet is or even what Python is. You find the relevant CRE and cherry pick the standard you know about. If you're a tester, you do not need to know much about high-level or extremely low-level standards. Find the testing tool or testing library that you care about. And procurement, obviously, you don't care about what is the German standard for cybersecurity versus the UK one. Just find what connects them. And bonus, all of these people now speak the same language. Speak CRE, CRE speaks the rest of the languages for you. Our next steps, we are releasing probably next week, but don't take my word on this, depends on open source maintainers. Probably next week we're releasing high-level standard mapping, starting with OWASP SAM, and hopefully we go down to SOC 2 and FedRAMP eventually, which gives us way more mappings. We are working to create front-end UX improvements, because the front-end is a list. Lists are not cool. And since we're doing filtering on the front end, it would be cool if you could save filters so you do not have to say things that are irrelevant to you. Here's our call to action, and here's, since we promised publicly what we're going to do, here's what we want you to do. Use it, as with every other open source project. Please use it. Start it on GitHub. Spread the word. If anyone here writes any standards, let's have a chat. I would be super interested in incorporating whatever you have into opencre.org. That would be fantastic. In return, you get links that will never break, unless, well, we're run over by a bus, but that's kind of unfortunate and grim. And thank you. That's all. Quick presentation. Questions?
I just wanted to say, well, I was going to ask you a question. When are you going to do SOC 2? And can you do that sooner than later? SOC 2 I need. But I just wanted to say a genuine thank you. As someone undergoing an ISO audit right now, this is invaluable. And this has been so helpful. So God, thank you and your whole developer team for your time and efforts.
Thank you. As an anecdote, we have some industry partners that have used OpenCRE to drastically reduce auditing times. It's one of the reasons we're doing SOC 2.
Are there any plans to expand OpenCRE beyond security standards? So perhaps to safety standards or other implementation standards?
That would be fantastic. It is currently not my expertise. I am a security person, but it's an open source project, and we are very open to the community to add mappings. If you would like to get involved, sure, it would be fantastic.
I was just wondering, do you have any plans to work with industry tooling vendors to incorporate this data in, and what does that adoption look like today?
So you said industry tooling vendors.
Yeah, that was like the same thing 3 times, I realize now. But I mean, so if you're doing an assessment, perhaps, and you're getting findings from Nessus or something, is there plans, are you working with industry partners to integrate this OpenCRE
Yeah, so that's exactly why I added Zap, because, well, when I was doing pen tests, it goes super hard to provide information, and I hate copy pasting, as you might have noticed. I spent 3 years of my life making an application, so I don't have to do that. Vendors are somewhat harder to adopt kind of an open source project, especially a standard that provides information. I don't know why. I didn't have much traction there. But if anyone here works for any vendors and wants to use OpenCRE, let us know. If you have any traction with vendors and you would like to push OpenCRE, please let us know. I'll buy you dinner.
So another question. More than pen testing, I see that it's good to integrate that threat modeling or requirements phase. So is there any, well, similar question to that, to integrate with any threat modeling tool like Irius Risk or something like that, or exposing as an API?
So OpenCRE is an API. The front end you saw is just my attempt at making a React app as a pen tester. On top of an API, the API is just a Heroku public instance. You can use it. We create API first so that it's trivial to integrate with anyone. With Irius Risk, I think I'm going to meet them next week, and it's one of the plans in the agenda. It would be fantastic if they integrated with us. There is other tools mostly OWASP, because that's the community I'm involved with heavily, that we are planning to integrate with. It's just slow adoption because open source.
And last thing, mobile security, I think would be good to add some standards from mobile, like the mobile security testing guide and that stuff.
We have a MASBS, mobile security testing guide. Ellie, the third CRE person, hasn't gotten around to yet, but it's coming.
Anyone else has any questions? Thank you so much.
Thank you.
All right, everybody. Thank you so much for the morning track attendance. If you can make it back just before around 1 p.m., we're going to start right on the dot with an incredible panel with leadership from OSSF, the White House, and Microsoft on the future of open source security. Please do come.
the one for the contributor to be.
Yeah.
It also leaves us the audience chair. The audience can ask questions potentially.
I just give it just one more second. Thanks for coming. We're getting ready.
I think, I don't know if we're up against Jimmy Well.
Yeah, I saw that.
The other big things.
All right, you ready to get started?
We're doing this for the camera.
Yeah.
All right, welcome back to the afternoon security track for State of Open. I am genuinely very excited to have a panel which I personally requested to the best of my abilities, because I think there's some really interesting discussions to be had. Let's jump in. So to start, can each one of you just give me a very brief description of why you are on this stage today?
Want to start, Anjana?
Hi, I'm Anjana Rajan. I'm the Assistant National Cyber Director at the White House at the Office of the National Cyber Director. I think one of the things that I'm really excited to be here today is that open source doesn't know borders, right? It's an international issue, and we need to start talking about international strategy from the ground up as we think about the solutions.
I'm Brian Bellendorf. I'm General Manager for the Open Source Security Foundation, and I lead a consortium of organizations focused on trying to raise the default state of security across open source software and secure the software supply chain. I'm here really to, because we find ourselves in a lot of conversations with the White House, with other governments, trying to help them understand kind of how open source works and what's really the right way to raise the floor on through policies, through investment across open source software when it comes to security, and what are the wrong ways and how do we avoid some of those?
And I'm Sarah Novotny. I lead open source strategy for Microsoft. And I'm here because, one, we helped found the Open Source Security Foundation and are continuing to invest efforts there. But fundamentally because security is a worldwide software problem, and we as open source leaders can help move the industry forward by moving our practices toward default secure and a more collaborative manner of engagement, of course.
Excellent. And I am Sal. I'm a developer, and I'm here because getting security right will make my job easier. The first thing that I really wanted us to jump into was the idea of sustainability for open source projects. What is it that we're looking at as risks and concerns around sustainability of projects, and what does that look like as a security concern?
I have many ideas.
Go for it.
Okay. One of my favorite is that big companies, Microsoft included, will often hire maintainers, but then have them potentially spend not their primary amount of time on an open source project that they were actually hired for, or because of that skill, because of that engagement. So I think there's a lot of understanding about open source and security that needs to be shifted around in our many companies.
Well, and to be clear, I think sustainability, since that's such a broad term, we're really focusing here on how does an open source project live to serve another day, live to serve another year, and frankly to serve the needs of its user community, to publish updates, whether it's new features or simply bug fixes. You'd be amazed the number of new bugs that are discovered in projects that have not had active development in years, and sometimes they just fall on deaf ears, right? Because it's the tree falls in a forest. Well, sometimes there's an awful lot of users, but actually not a lot of, if any, people contributing to these projects. And so sustainability really does come from how do you have a team of people of diverse backgrounds, diverse incentives, diverse motives, I think, actively maintaining and having a sense of obligation to the end user community, still in the framing of a gift, because open source software is a gift given by its maintainers, by its contributors to the wider audience. And so sustainability comes down to how do you recruit more people into that sense of maintainership, that sense of stewardship, into the development team, right? Recognizing there's lots of different ways to contribute to a project, not just code, but documentation and others. And historically in open source projects, a lot of that has come from companies recognizing collective self-interest, putting devs on a project because they might be just above it in terms of providing support. They might be way up here in that you're a search engine, but you know you have to help improve the operating system, right? But for all these reasons, how do you bring more of those kinds of stakeholders into an ecosystem and keep those fires burning?
And align incentives.
Yes, very much.
Yep.
A very big challenge.
Yeah, I agree with everything that was said. Those of you who are following US politics, you may remember that last night our president gave the State of the Union address, and in the speech he talks a lot about infrastructure. And when we talk about what it means to invest in infrastructure for the long haul, we understand that when it comes to roads and bridges or clean water, that if you don't maintain this over time, your bridges will collapse, your water will have lead in it. And one of the things he said last night was the historic passing of the bipartisan infrastructure law, which was one of the largest infrastructure bills that have been passed since Eisenhower invested in the interstate highway system. And in that bill, open source software is specifically called out, which I think is really exciting to see.
Yeah.
And when we talk about what it means to maintain this, this has been talked about a lot at this conference, right? We talk about free software, and it's a bit of a misnomer because it's not free. There is labor that needs to go into it. There needs to be physical infrastructure investment. There needs to be a long-term strategy because our economy depends on it, our national security depends on it, our democracy depends on this infrastructure. And so just to echo, what my peers have said is we need to start thinking about this as any other piece of infrastructure, that if we want our bridges to stay up and we want our water to be clean, we also need our software to be secure and safe and resilient.
This ends up being a shift for a lot of people. This free like a puppy, like free like sunshine to free like a puppy, and then to recognizing that we have all these dependencies in all of our software, and that this should be a part of cost of goods, even if it is only a social contract and not a legal contract at this point. Or maybe we have to move to a space where there is a responsibility of return, like some of the copyleft licenses exist with an expectation of return of code. So we really have to shift the mindset to this is something that goes into a product we are producing. It is a cost of goods.
Yeah, I think, so I want to be a little bit careful about the metaphor about highways, specifically because it's radically different. I don't want us to, we could not possibly centralize the support of open source in the way that we can centralize physical infrastructure because it is decentralized by definition.
Mm-hmm.
Or perhaps another way to say it is, I don't know if I even have the legal right to go and fill a pothole.
Exactly.
Exactly.
I might like to,
Yeah.
But yeah.
Yeah, so I think we're in a really interesting space where we got a lot of attention on a problem that's going to require an incredibly new approach. And as we step towards that, what are we doing to fill the massive, massive gap between the security jobs that we need to fill and those who are qualified to fill them?
Yeah, and I think just to plus one that, we're talking about a supply chain that is not linear, right? We're talking about an incredibly complex network, and I think you're 100% correct that we cannot just pluck solutions from decades ago into the 21st century, and I couldn't agree more. I think from a workforce perspective, people need to understand that cybersecurity is by design an interdisciplinary field. That we need engineers and cryptographers, but we also need people who understand other disciplines that are so critical for this to work and for people to feel bought into this. Yesterday I spoke about my time being a CTO and responding to Log4Shell, and I don't think people realize that when cyber vulnerabilities happen, it affects everyday people. It's not just the cyber community as we kind of traditionally define it, or even how it's perceived. And so a lot of what we're working on at the Office of the National Cyber Director is what is the workforce strategy for this really important issue. And my colleague Camille spoke about this at the plenary yesterday, but there's essentially, we have kind of four pillars to our workforce strategy that we're starting to think about. And I think first and foremost is understanding what does the national workforce need to look like for the long haul. This includes private sector, the open source community, academia, research institutions, and yes, we also need to think about the federal government as well. And so when we think about what does it mean to build that talent pipeline and to build these skills over the course of this somewhat new industry that becomes a really core priority for us. The second is then thinking about how do you get people into this ecosystem in the first place, and that's where the education and training conversation becomes so critical. We think a lot about what does it mean to not just work with the elite engineering institutions, but working with community colleges as well, non-traditional education systems, and post-secondary and secondary education from the jump to make sure that the next generation who are digitally native understand that cybersecurity is part of the technical ecosystem. And then the final piece is, we talk a lot about how do we make sure that we're not putting the burden on, the individual or the small business or the mom and pop shop that does not have the resources to withstand a cyber attack from a nation state. But in spite of that, we still want to make sure that they see themselves as part of the solution. And so what does it mean to create a digital awareness strategy to make sure that everyone understands the role that they can play? And when you think about these 4 pillars, they actually are a flywheel that kind of build off of one another. And so when you think about how do you build a workforce strategy, it's more than just talking about jobs. It's about recognizing that, particularly in the open source community, it is a different model than a corporation. It is a different model than a centralized ecosystem, and you have to kind of think differently about what it means to build resilience for the long haul.
Yeah, and the reports are that there's hundreds of thousands of positions unfilled that call for people with certifications in cybersecurity, and so one part of that is certainly how do you fill those kinds of jobs, but I really love the point that this is everybody's responsibility and parts of every role that play into that. So at the OpenSSF, one of the things we created was courseware. It was about 15 hours of content that anybody who's a developer at any level, frankly, should take, because it encapsulates here are the most common types of traps that developers fall into that become the source of vulnerabilities later. Things like not understanding how to sanitize user-contributed input before you do something dangerous with it. It's a great set of things that aren't really taught in computer science courses, and regardless, most open source developers are not formally taught in computer science anyways. I mean, a lot of people in CS are self-taught, especially just to keep up with newer languages and the like. So that's one example. Another example is even going even more basic. We've published a set of concise guides for how to evaluate open source code and projects, and frankly all software, as to whether you can trust it. Like, does it exhibit certain things that we see about projects that do take security seriously, right? They have a published security team, right, that is reachable by an email address, right, to report a vulnerability against. Do they have test scripts, those kinds of things. And the flip side of that is another guide that we put out, which is how to make your project more secure. And here's like the really short guide to do that as well. Lots of this other kind of content that has been missing, frankly, out there that really tries to hit developers at all different levels, and again, try to up-level the state of understanding about how to build secure code amongst the open source community, or frankly, all developers.
There's another interesting aspect, all still in the education and sort of pushing this forward, and some of that is pattern matching, in the sense that we don't have a lot of good listings of best practices for a new open source project. So there's a working group inside the IEEE, which is also coming up with what does it mean to be a project? How do you set up best practices? What are the common patterns, which is going to become, we hope, some set of standards that we can then point to that say, this is what it means to be a secure project. Because I think sometimes secure project is conflated with has no bugs, which is not possible to confirm beyond, I don't know, the next 6 minutes, maybe, if Sal's not hacking at it. So I think there's also an understanding that responsibility becomes a shared responsibility. We talked a little bit about that, and it becomes a shared responsibility both as a consumer of open source, but you also need, with that understanding that there's a shared need there, you have to also understand that you have to contribute back to it, and you have to participate in all of these ways to make sure that you're, say, I don't know, using a curated open source inside your development, so that you have if you don't have the skills, you have some sort of support or cover from an organization that will help you there. Now, how do we bridge that gap? We do a lot of performative art in open source. We keep talking about security in open source. We keep showing what that means, because if you're self-taught and you don't have that, It's hard to match that pattern. And we have the education problem, which is security is not generally taught right now in CS.
Yeah, I just have one concern broadly as we start to encourage a whole generation of new cybersecurity researchers specifically, but the hardening of open source as well. I think it's excellent that we focus on educating the maintainer class, educating contributors, and we create as secure systems as we can.
Yep.
I also cannot walk off the stage without actually speaking to the underbelly of cybersecurity, because right now, there's probably, absolutely less than 1,000, but about 200 people who are very, very good at hacking. And the real difference between a white, gray, or a black hatter is typically I'm out there learning in real time, experiencing, trying to do a bug bash, do something like that. I become a black hatter not because I have bad intentions, but because I've raised a vulnerability. I want to disclose it to an open source package, and I'll get contacted, theoretically, by a nation state that strongly suggests that I don't. That is why, in my opinion, I would surmise that Log4j, Log4Shell was probably raised dozens of times, and it was only released several weeks after the Ukraine offense because it was no longer of use. We're going to encourage a generation of people to jump in, put your hands on the keyboard. We have to figure out how to protect that.
It has to be, you have to align incentives, and a nation state offering incentives for a 0-day is a really tough thing to compete with.
Yes.
So speaking specifically to Log4j and Log4Shell, there were people who had raised, Mark Curphey has an example of a tweet that he went out where he said, this stretch of this code I'm worried about because it doesn't look good. At a conference in 2017, he gave a talk about this, right? As like a flag that I'm sure this was a bug that had been found by nation states or other actors and had been kept confidential. The one that actually got reported was discovered, interestingly enough, by an Alibaba researcher who was also an Apache Software Foundation member, or a member of the project at least, I'm not sure if a full member of the foundation, reported it through the appropriate structures.
Nice.
And they started to do a coordinated disclosure process, and then it leaked because of an inadvertent disclosure, and an inadvertent message during that. Because not a lot of devs know how to do, in fact, we published a guide for this to try to help them to do coordinated vulnerability disclosure, because it's kind of important to make sure you have the right patch. Maybe there's other bugs that might happen, and that was the case on Log4Shell, was that there are actually 4 different CVEs that rolled out over the course of 5 weeks that compounded the problem and compounded the patching problem. And frankly, this is a bug that could have been found for about an $80,000 or $100,000 source code audit by a third party, right? And one of the problems here, and this was something that was cited by the what was it, the Cyber Defense Review Board, is that right? Cyber Safety Review Board, CSRB's report on Log4j that came out last July, was there wasn't simply the cash in the back pockets of either the Apache Software Foundation or any of the individual devs to pay for that 80 to 100K security audit, right? Think about like the return on investment. And we've been able to spend that, or buy it on the black market perhaps, but like at the very least, like do a third-party audit, have remediated that, and then avoided this kind of, what it could only have been a multi-billion-dollar industry disruption over ruining countless people's holiday breaks, right? So, the fact that it was a Chinese researcher, I mean, Alibaba, who is kind of, dinged anyways with the Chinese government, they did get a lot of unwelcome kind of feedback from the government for not having told them first. But frankly, I think there was enough. Inside of the open source community, there's a recognition that there is a role for government to help facilitate the right kinds of processes to happen, but that if it starts to become restrictive in the form of we've got to only notify the nation state who's the, the person who's the citizen of, discovered it, or notify them first before telling anyone else, that's going to create advantages for one party, disadvantages for other, and disrupt a lot of what are otherwise some very delicate interests to keep balanced here. But that the long term, the game theory is everyone's security is better enhanced by working together as a global community to solve this in the technically the right way and the path that is the least disruptive for everybody.
Yeah, and I think we talk about what are the root causes of the security vulnerabilities in open source in particular, and the incentive structure for reporting a CV is highly misaligned.
Yeah,
Right?
broken.
Why would you call the police when you
Yeah.
bug in your own code? I don't think we've really understood like what the end
Yeah.
game is for the broader ecosystem. And again, just to foot stomp what you just said around it's like a game theory problem that counterintuitively everyone wins when you have a secure and resilient internet. And I think that's really what, at least at the Office of the National Cyber Director, we talk so much about that resiliency is the end game, right? Building security benefits all of our national security interests, our economic interests. And yes, that means our adversaries might also have a secure and resilient internet, but you know what? That's actually the price we want to pay for our best interests. And I think that is a kind of a provocative shift in the conversation. And I think you're completely correct that really understanding like what does it mean to be cyber secure, it is not a zero-sum game. And that we have to start thinking about this differently in the same way that we think about having just an ecosystem that is healthy and thriving.
I think that leads us really well into the next question. So open source is democratic, distributed, chaotic. That's the part that I like. How are nation states specifically right now observing and recognizing their relationship to open source, both as consumers and as regulators separately?
You know, I think I said this yesterday. I'll speak for the U.S. government, of course, but you know, I think it took Log4j for the U.S. government to start realizing that this was an ecosystem worth paying attention to. And people ask, you know, is this a new conversation? I said, no. This forum, this conversation is not new in the engineering community. It's new in the fact that you're now talking about it at the policy level. You know, I think one of the things that we are really thoughtful and intentional about how we frame open source is first by leading with the fact that this is a force multiplier for good. And if you lead with that conversation, you're going to think about policy very differently. And so first, ask yourself, like, why is this so important? I think someone mentioned it yesterday in the plenary. You cannot build a successful business if you're not using open source. Like, you will not be able to compete, period. You will not be able to defend against authoritarian regimes if you don't have open source. Like, those are the first principles we need to talk about. When you have that power, of course, then you can think about the security risks and national security implications. And so for us, I think how we're framing it at the Open Source Software Security Initiative that we're leading across the executive branch is recognizing that there is a very complex and nuanced thesis around this. And so as we're thinking about solutions, it cannot just be a threat that we're scared of, but an opportunity and an ecosystem that we must defend and must protect. And so I think that's kind of the core framing for us, first and foremost. For many emerging technologies and nascent technologies, as well as long-standing technologies, is how do we make sure that we have respect for the craft of engineering first, and then think about what it means to regulate and build policy around that second.
In 1999, the Supreme Court decided in Bernstein versus USA that cryptography, right? Public key crypto, the ability to secure communications, was no longer to be considered a dual-use munition, or a dual-use technology that was classified as a munition and regulated by the State Department, at which point you were prevented from exporting, as a US citizen, exporting any software that could do more than 40-bit encryption, or you could go up to 128 if you followed a bunch of rules. But obviously open source code has no limits to the key lengths of cryptography that you could use, because it's just a variable in code you could change, right? That act, before Bernstein passed, that fact kept us from being able to build secure protocols natively into the internet, right? It had to be bolted on after the fact as SSL and TLS, and up until '99, it was imported into the United States from Britain, from Australia, from other places where cryptographers in many cases left the US to go and do their work. And so Bernstein, that decision changed that. Then at the Apache web server, we could build it in directly, and it was a much better outcome. And so there's always been this like, not adversarial perhaps, but certainly a strained relationship between the tech sector and frankly the open source sector and government policy. Because I think even well-intentioned policies can sometimes end up changing those incentives in such a way that it can really throttle a lot of the dynamicism that you see inside of the open source community. And the current example of that is the proposed bill in the European Union, the Cyber Resiliency Act, which does some of the right things in terms of encouraging is put too soft, mandating the use of certain kinds of scans and process audits and tooling by open source software, especially that used in critical infrastructure. But instead of encouraging it and providing support and help and carrots, it's got the stick of a mandate of, you don't get to disclaim liability anymore as an open source developer when you put it out. And that is a pretty damaging thing. It could lead us to a similar situation we had before Bernstein in the States, but in the other direction, where open source projects decide not to export to the European Union, right? Or open source devs inside the EU decide they can't do their work safely without running the risk of losing their homes or being fined or things like that. So there's a lot of hard work to do here, and I'm really encouraged by conversations that we've had that even folks in the European Union and certainly here in Britain we have about what are the right ways to apply that policy in constructive ways to move things forward. And I'll just end with, for me, one of the best examples of where collectively we took an internet ecosystem and up-leveled it to a more secure default was through the migration of the web from an entirely unencrypted platform where everything was going over the network in clear text to what is now, 98% encrypted traffic, HTTPS. And it was through a sequence of phases that I'd probably call carrots, then changing the defaults, and then sticks, right? It was the green little key at the top of the browser bar that said you're on a secure website, congratulations. So for your banking stuff, you really want to look for that. To changing the defaults by getting Let's Encrypt out there and making it very easy for anybody when you're installing a web server to automatically get the key and rotate it every 90 days, that kind of thing. And then the stick part was when the browser makers finally said, no, we're going to put up a bunch of warning signs, maybe even entirely block you if you're trying to access websites that instead should be encrypted. So we need to think about the same things when it comes to adopting security practices and policies and that sort of thing. We can't just rush into mandates and put the burden upon even what seem like well-funded entities to be able to do this work. We've got to progressively work our way through it and learn as we go. Sorry for the long answer.
That's a great answer.
I think there's an interesting overlay to your answer, which is not answering your question, but is maybe making an ask, Anjana, to nations everywhere. You just happen to represent one. But one of the challenges as an organization working in open source, as an organization trying to comply with regulation, is with so many different regulations popping up, maybe being European Union this or the United States this, as we are going through this and learning, let's try really hard not to end up conflicting, because that's our biggest risk. Is what if the CRA gets passed in the EU, and then we in the US make some entirely different choices. Like, then it becomes much more difficult for us. So again, this is a global community, and this is absolutely not the moment, even for all of the crazy in the world that's happening today, for us to be nationalistic or trying to get an edge in one way or another as a nation around open source. It goes right back to we are better if our internet is secured, even if our adversary's internet is secured.
Couldn't agree more. And I think, I said this before, this open source software security initiative, I hope, is the beginning of a very long-term sustained effort, long after I leave the White House. And you'll notice that we talk about international engagement in the earliest months. It's a big reason why we're here at State of Open, for that reason. This is a internet native community. It is not a company that was found, created in the United States that is scaling globally. And so the approach to international harmonization around regulation has to be different. And so we need to be starting from day one thinking about what does an open source ecosystem look like around the world?
Yes.
And then build the concepts first and the thesis first, and then think about what does the regulation happen second. I think you mentioned something around the concept of what are the incentives for this? I think what I love about the open source community is that there is a deep shared values in our ethos around cybersecurity. And I think people forget that cybersecurity is not a stifler of innovation and economic growth. It is an enabler. We're seeing so many new companies and new cryptographic ideas come out because we're now recognizing the stakes are so high. And I think for us as the open source community, we can talk about this and say, this isn't a compliance checkbox. This is actually some of the most brilliant evolution of technology that we get to see because we care about this and we understand the stakes. And I think there's an opportunity for this community to lead on how we talk about technology more broadly, which I think is a call to action for all of you to say that it is not just up to government officials to talk about this. It's about engaging with the experts who are actually doing the building. And I think that's kind of one of our core principles, is making sure we're talking to the folks who actually know what they are building and doing first, and making sure the regulation is inspired and influenced by that.
Absolutely. I will just say one thing to that. Particularly in the UK, we need much more sort of education and people sitting in leadership that understand it.
Mm-hmm.
I mean, I've got a lot of conversations with regulators where they've got a, it's a box approach. They're like, at some point, all this, I can think of it as a box. What kind of stamp can I put on it and call that done? And that's just not appropriate, because that's not how any of this works. And I always put it the same way. We wouldn't allow that kind of phobic behavior around the thing you're regulating in any other sector. It would not be appropriate for someone to regulate the automotive industry if they were afraid to drive cars. We need more people who are competent and technical enough to inform. That's why I'm really grateful that you're in the position you are. I think from that, I've got one final question that we could probably expand on forever.
Ooh, yeah.
What are we going to do to make open source secure by 2030? And very specifically, the answer matters to me, because if the internet is not secure by 2030, I'm just gonna unplug and go live on a boat.
Well, Sal, I think you've given us your retirement plan.
Yeah.
Because the internet won't be secure in 2030, just for the same reason that there will always be security holes yet to be found. Sorry, sad to say. My hope is that we can avoid something as damaging or as disruptive as Log4Shell was, as Heartbleed was before that, these kinds of major earthquakes that do a lot more damage than they need to, right? And from a risk-adjusted point of view, it's a tremendous drag on society. It's a major cost, and it's a discouragement to innovation as well, right? So, there are lots of things that we can do to bring down that risk. There is not one silver bullet there. There are, there were a set of 10 things that we identified about a year ago in response actually to the Log4j breach, but also specifically the White House asking us, you all have some cute ideas there at the OpenSSF, but what does it actually take to close some of these things that you found? And so we developed something called the mobilization plan, which was a set of 10 true north kinds of things that we could do across investments in third-party code reviews, in adopting digital signatures, in better education. We tried to map them out and say, what are some useful goals that are actually short-term goals that are achievable in 2 years, that have kind of a minimum viable approach to what would it take to just make a double-digit % in the problems that they identify. Frank, and you were part of that process in writing the document. Our community kind of scrambled for 2 weeks. It was like cramming for a final or writing your PhD thesis in the last 2 weeks of your PhD career. Anyways, it was, and we thought it would be billions of dollars. Like this would be, there's a lot of big problems there. It turned out that it called for $150 million over 2 years, right? If you added up all those. Now, we've started the clock on some of those projects. Others are still kind of in flight, and we're trying to figure out how best to support them. But there's a lot of low-hanging fruit, is my point. A lot of things where, just like with the example with Log4j, no one had that 80K in their back pocket to be able to spend on a third-party code review, and frankly, you should do it every year or 2 or 3. But if you could organize enough to identify what are the 200 most critical projects to do this year, 200 times $100,000 is $20 million, which starts to sound a lot more tractable. Things like setting up a emergency response team for open source projects, so that when a under-resourced team who knows that they're widely used, who knows that they could use some help in coordinating or even just figuring out, is this really a bug as bad as we think it is, and need that help in a confidential way, a staffed help desk to be able to go and help them do that. That takes real resources, right? That's unavoidably, right? But adding them together is not at the scale of the positive impact we could have, is not out of the question. And so that's what we put this plan together for, and has led us in terms of how should we organize our internal efforts at the OpenSSF? Continue to really drive the volunteerism and the collaboration amongst the community that has led to the kind of leverage we get. But when we're going to go out there and start asking for money for some of these things, so we make sure the plan is extremely well vetted and has some very short-term kind of goals. And then, frankly, revise it each year, perhaps even every half year, as we go and learn and find new low-hanging fruit.
Yeah, and this mobilization plan, a lot of that's just, it's open meetings, GitHub, that's how I'm participating. If you've got opinions, go submit a PR. You might not necessarily get accepted, but if it's a good idea, yeah, then you've engaged, you've contributed to open source. And we particularly need people from different backgrounds coming in at this time and providing additional support, because we got a bunch of cybersecurity people that are like, we know how to do our job, but the sort of support around those processes is interesting. And I also have to appreciate that the mobilization plan just really cleaned up the slack. Now everyone's organized. I'm like, I know exactly where to go to have my conversations, so thank you.
I appreciate that, thanks.
I'd like to sort of, within that, OSSF and Alpha Omega, because I actually find what Alpha Omega is working towards really interesting and valuable, because every time I see Jonathan Leach, I say, if you do your job just a little bit better, then I don't have to have a job. Because in some ways, what we're focusing our efforts around right now are training, education, mobilization, making sure that we handle the status of toil right now, of developer effort that's being really wasted on really unproductive repeat cases. But Jonathan's going through and finding vulnerabilities at a class level and trying to report and remove those. And it's those sort of incredibly effective moments of using this technology to remove the end. What am I? So okay, here's what I'm trying to say. We've all been doing cybersecurity as individuals, in corporations, maybe reaching out, patching, working with open source. But there's also another side of here of just do this intelligently, do this using computation, and I love that approach.
But it's still fraught. So there was 2 weeks ago, there was a press release put out by a company called Trellix, who, using a bunch of automated tools, went and scanned a couple million repositories on GitHub that are in Python, and found 61,000 projects that made unsafe use of an old Python library, tarball or tarfile library, I think it was called. And this was a bug actually in tarfile from one point of view. They refused to fix it because they said it would break POSIX. We don't have to go there. The problem was 61,000 projects used this thing incorrectly, didn't sanitize inputs before calling into it. And Trellix had written a script to go and find those systematically, which is kind of hard, parsing and understanding. It's not trivial. It's not just a grep, right? And then proactively, this is the really hard part, came up with pull requests that would fix that insecure usage, that would just add the sanitize call to it, right? Submitted those as pull requests back upstream and sat there and waited. And after 3 weeks, how many of those 61,000 projects do you think actually clicked the button to accept the pull request that was like a 2-line pull request to make their project no longer vulnerable to a 2007, that's the part I forgot to say. This bug has been a known CVE since 2007. How many of them do you think accepted that pull request? Okay, 1,000. I'll save it. And
Thank you for saving.
Yeah. So 1,000 out of 61,000. Now, admittedly, a lot of those 61,000 were weekend hacks. There were people who had done a one-off fork to play with it. So there's this very long tail, and a hard question to ask is, where do you cut off the tail? Yeah. How many projects do you actually care about? And it's going to be more than 10,000. It's going to be less than 10 million. But this is securing open source, securing the cyberspace, securing the internet infrastructure. There is that long tail, and you have to ask how many of those matter. And then of those that matter, I would wager 3,000 of those probably should have closed that bug, should have had a maintainer community to do that, to really help make sure that it was a 99th percentile of users that would no longer be affected by that CVE. But we have to think about those kinds of scale. Yeah. And that's a little bit what one part of the OpenSSF, something called Project Alpha Omega, is setting up a major scanning infrastructure to do like what Trellix did, scan these things, report them at scale. Jonathan Leach, a researcher we just hired, has been doing this. He gave a DEF CON talk in 2022 about how to do this. Has 6 campaigns underway now, but we will be lucky if we get 10%, close up. Because after that, what do we do? Do we go visit them at their homes and tell them to accept the pull request? I think we gotta we know that that's the major part of the challenge at the end of the day, is getting people to care enough about this.
Oh no, you can do that. You go and you find them on Slack. This is, I call it security shaming.
But I think this is, I think where it's exciting, I think we're talking about mobilizing against a generational defining crisis, right? This is why I make the comparison to infrastructure, is not that the solutions are the same, but the urgency is the same. Yep. We're now, I think, getting people to care about this at the highest of levels, which I think is a huge win for this community. But now I think there's a chance, again, for the innovators to now lead us to phase 2. A CTO is being asked to say, hey, I need to tell you what's in my software supply chain. This should be table stakes. I should not have to manually create a bill of materials. I should be able to rely on my GitHub repository to click a button and update that every time I submit a pull request. I should be able to integrate a CVE list from MITRE to say, is there a vulnerability in this supply chain? And GitHub should block anything being pushed to production if that hasn't been met. We should not be relying on manual effort to get the other 60,000 repositories to not get updated. So this is, again, call to industry, call to the community. This is where the technical innovation and the product innovation, I think, is the next phase for all of us to say, okay, now that we agree about the policy and the concepts, how do we now automate this? How do we now make this the cybersecurity by design? I think I just want to go back to your last question around what do we need to do by 2030? And I think this is a perfect question to ask, because it reminds us this is not a short-term solve. This is a long-term vision that we need to lead on. I think Brian and I have talked about this before. There is no silver bullet. These are complex systems problems. If it were that simple, we would not be sitting here having this conversation. And I think we talked about there's a handful of 10, 12 key recommendations that can happen. And I liked your framing. It's how do we play chess, not checkers? We can spend all of our time playing whack-a-mole and trying to patch every single thing, or we can think about what are the solutions that actually get us ahead of the threat. And one of the many solutions that I think have come up from the open source community that have influenced us at the White House is one that I spoke about yesterday, which is the adoption of memory-safe programming languages. If we can start talking about how do we recognize that we're making our lives harder by just creating more surface area for risk, we don't then spend our time on the hard vulnerabilities. And to me, this is I wouldn't call it a low-hanging fruit, because nothing about this is easy, but we will never outrun vulnerabilities. We will never be fully secure, right? Software is a living organism that requires nurturing and constant attention. So we need to be really thoughtful about where are we putting our top cybersecurity researchers' attention. I don't want to spend their time patching memory-safe bugs, because that could have been prevented from day one. And so I think we will always need to have those cybersecurity researchers focusing on the hardest part of the problem, and we're wasting that talent on patching bugs that could have been done from the beginning. And so our call to action, including folks at Microsoft, so I'm going to ask you for a favor, and you go back home as well, is we need to start asking the biggest infrastructure players to make that shift today, because it's going to take a lot of time and a lot of money and a lot of leadership and courage to shift these big institutions that have been building software that powers the global ecosystem, but are building on memory on safe languages. And I think this is the one thing that is so exciting to us, because this is where every top cybersecurity policymaker and every top engineer agree on this. And we should not waste this moment, and we should take advantage of the fact that we've got good engineering practices informing good policy, and mobilize against a common call to action.
It's interesting you bring up memory-safe languages. That's where I was headed. For me, and in fact, one of my team members is actually just kicking off the memory-safe language working group this week at the OpenSSF. And so we are very much investing in memory safety, in looking at where we can mitigate things, because there are hundreds of thousands of millions upon billions of lines of code in C and C++. And that is going to be a very long fix. That's a long haul, even if you want to.
Well, and I don't think the objective should be eliminate all use of memory unsafe languages, because there's still a lot of COBOL out there. And I don't think COBOL is memory safe. Maybe it is, but no, but it's going to take, But instead, what you could do is focus on what are like the really critical pieces. So for example, the group, the same office that put together Let's Encrypt has put together a proposal to go and fund memory safe replacements for NTPD. Does anyone know what NTPD does? It does this little thing which is keep time synchronized across the internet down to millisecond, microsecond levels. It's something that if it were attacked, we would have a hard time rebooting from that. Likewise, DNS infrastructure. We all take it for granted. Bind is written in C. Bind has been updated but also attacked quite often in the history of the internet. So I think there's a couple of critical places. You could prioritize work.
TLS.
The Linux kernel.
So another one they're working on,
TLS.
TLS.
Oh, I'm sorry, Russell's, which is mostly there, but really to be a drop-in replacement for OpenSSL is still a lot of work to do there. And it's not just writing the code. This is the other important thing. To get these projects to get that flywheel going, you need to invest in building the stakeholdership around it, building the DevRel, making it so that there's this user community that can become contributors communities, all the kind of stuff that we know makes for well-run open source projects. Even the Linux kernel now, by the way, allows for modules written in Rust. And I suspect that's the nice thing about Rust is you can kind of replace things piecemeal and go in and write replacements for the more critical pieces, even of a large software project. So I think there's a lot to be said for that initiative. And it's important to solve some of these systematic issues at scale. It is also one of those 10, 20-year kinds of projects.
And can we actually go deep on this OpenSSL piece? 'Cause I think this is where complex systems thinking is actually beyond just engineering. When you think about OpenSSL, and again, this is why the open source community should lead on this, they should be leading on this and saying we need to rewrite this in languages that are not introducing vulnerabilities. And that's a big ask, but that's a bold ask that we need to hold our own community accountable for. And then we look at the alternatives like Russell, Libsodium, all these other TLS providers. How do we help them become players that can actually support government critical infrastructure as well? And so I think there's a push and pull that the open source community can call upon. One is asking the government to say, how do we make the process to become government approved infrastructure easier, more inclusive, less intimidating? But also, I think as the open source community who are talking about security, we need to lead. We need to be on the forefront of this, and when we're not, it makes it very hard to then argue that we are something that should be powering the broader ecosystem. So I think it's a shared accountability that at least certainly we are thinking about those push and pulls, but I think that's, again, a call to action for this community is what does it take to be seen as thought leaders on all fronts.
Absolutely. Well, I believe we are at time, and I think that's an excellent place to stop for the moment, but I think this is a conversation that we're going to be having till 2030.
At least.
And then we'll get you on your boat.
Thank you so much.
Good stuff.
Ready? All right. Continuing with the security track, I'd love to invite Rao onto stage, who is going to talk to us about essentially a foil to my talk earlier, open source supply chain security from an enterprise perspective. Welcome to the stage.
I think it's on this side. Yeah, this works. Perfect. Thank you. Shall we start? Good afternoon, everyone. Thank you for joining the talk, and also thank you, Open UK, for giving me opportunity to speak to you from this side of the podium. And thank you, Sal, for running the security track so smoothly. I'm loving all the talks. So my name is Rahul Lakkakula. I'm a head of product security or executive director in JP Morgan Chase. My focus has been securing the developer platforms in JP Morgan Chase and also making sure application development is secure by default. That's been my focus for the last 4 years. And today I'm going to talk about supply chain security from enterprise perspective. Supply chain security is a very broad, huge topic, so there's no way I'm going to cover it in 30 minutes. So the way I'm going to approach this is go over as more of a primer on software supply chain security, touch on some of the important points, and then maybe give an opportunity for you to kind of explore further. And I have my contact details in the end, so we could go in details later. So first of all, why does software supply chain security actually matters? I think it's probably obvious by this time. You've seen so many presentations, but I have to have an obligatory log4shell deck, right? So I have this nice slide with log4shell, the Spring4Shell, and few of the things. So I'm not going to go into each of the individual incident. That would be a bit boring here. You could find that from any of your favorite browser, searching it. But I'm going to look this from a different angle, like two approaches. One, why does it important from an enterprise perspective, any of these incidents? The difference is traditionally an attack on one of the systems probably has an impact, but it's isolated to a few systems, right? You could contain them, fix it, you move forward. Then you act. But with the supply chain security, you're talking about an impact on hundreds and thousands of the systems at once. So the impact is so huge, and actually all enterprise actively put all hands on deck to deal with these issues. The Log4Shell is a good example. Basically, pretty much all of our security guys lost vacation before last Christmas. And then there's another angle to look at it is, there's also the traditional enterprise security protection mechanisms are more of a perimeter-based, network-based protections, right? Like firewalls is a fundamental, our shield. With this software supply security, these are all embedded deep into your software chain. And these are actually running within your network and sometimes actually running at a higher privilege. So these are not something you could work with the traditional security protections you do have. So that makes it a bit different beast to handle. Then there's another angle we could look into. So if you look at these attacks, right, obviously the most common one is the ones applications embed the open source software or a third-party software which has a vulnerability. But there's also a new type of attack we've seen with the SolarWinds is it's not just a vulnerable software. It's actually the malicious users get into the network of a supplier network, in this case the SolarWinds supplier, and actually they work on their build pipeline. So they injected the code inside the build pipeline. So the traditional ways of doing a checksum, verifying the vendor is secure, are we doing all the due diligence at the time of onboarding? None of them going to work. So these are new type of attacks are coming into the supply chain that makes it a very, very important one. I think if you haven't really convinced by the time, obviously this is the slide everyone showing since the beginning of the conference, 700% increase in the attacks. But also going further, the future is also not great either. Gartner did a research, and they're actually expecting by 2025, within like few years, pretty much half of the whole industry going to have some kind of attack experience by the time through supply chain. So what is a software supply chain in general? From an enterprise perspective, in a simple term, it's when a developer commits the code till all the way application is deployed into production, or if it is an end user product, the product is deployed to the user, right? That's the simpler case. That's the case. You don't actually use any other software, any other packages. You're writing code from scratch and you're sticking to it. But that's not the case in most cases. So the software supply chain actually involves all the supply chains coming with the dependencies you use. So you're starting with the beginning of each of the dependency and their dependencies and their dependencies and there. So it's actually a chain of chains for any type of smaller to big companies and enterprises. It makes it really different. So like for the enterprises, it's not just that application supply chain. We do have multiple levels of supply chains. We do have vendor supply chain, because most of the banks like us, we use a lot of vendors. They have their own supply chain, which they're actually depending on all other suppliers and also open source vendor software. We also have hardware supply chain, from like routers to firewalls to desktops and any other hardware. At pretty much all the hardware at that one point runs a software on their hardware, right? So you're talking about the supply chain coming from that. Then we also have the whole SaaS ecosystem. There's a lot of SaaS vendors like the banks use and most enterprises use. That's a supply chain we don't have much visibility into. That includes the cloud providers, right? So you're seeing this keep going on the list, and then you add these telecom providers also have supply chain. The whole 5G equipment, 5G networks we use in the enterprise, you have to deal with it too. So if you look at that, it's like there are multiple supply chains in an enterprise. But the reason I think the open source supply chain is still important is you all know like most of the modern applications, 90% of the code actually comes from open source. So end of the day, you could actually say securing an open source supply chain actually helps with any other supply chain too. But in the enterprise, we have to deal with all these too. And I'll touch briefly on some of the efforts going on in this area from a public sector and also the industry-driven initiatives. This is the one slide I probably need to look at the notes because I don't want to say something wrong and get in trouble with government folks. So this all started with 2021 presidential execution order in USA. There are a couple of them. And then most of the last year has been focused on how do we turn those executive order into more actionable guidance and documentation. So if you see Office of the Management and Budget, OMB, Office of the Security National Intelligence, OIDA, and the NIST, they're all like produced a bunch of documents last year, which focusing on like providing guidance to the development of the. So the kind of interesting thing is most of these started as a federal supply chains, but there's a lot of focus on supply chain security last year, so it's actually kind of expanded beyond just the federal supply chain, and private industry is looking into it, including us, like focusing more on how do we improve our security too. And then UK is not lagging behind. I mean, UK, the 2021 government actually made a call for view on software supply chain security. That's basically kicking off the nation's cyber resiliency initiative. Then we also saw last year, this National Cybersecurity Strategy 2023 got published, and then the end of the year, the UK government issued a proposal for legislation to improve the overall UK cyber resiliency. So there's a lot of focus being there. From the industry side, obviously Brian was talking about the Open Source Security Foundation. I'm actually on the board of the Open Source Security Foundation, so I get to observe from closely. We actually came up with a 10-stream mobilization plan last July and presented to the White House administration. Actually, I was in the room when we presented that one. There was a good focus on that. Now also, it's not just OpenSSF. There's other industry groups are actually looking into it. FSISAC, which is a group with financial institutions. They started a supply chain working group last year. I'm actually part of that group. And then also the CNCF actually have a tag security. They produced a software security factory reference architecture. So there's a lot of moving parts here. So this is actually a best time if you haven't involved with any of them to get involved and start understanding those initiatives. As the picture shows, it's actually still a steep hill to go through, so I think we all need to work together. Then what are some of the key strategies if you're looking this from an enterprise perspective, right? for that matter, actually, any company, right? It's relevant for any size. First of all, you need to understand how your development practices are done in the firm, which is actually is not that easy for a big company like us. So you have to understand there's actually internal development goes on. There's outsourced development goes on. There's actually not just the software development. There's actually development happens outside of the software also. The groups, they bring in software and they develop like a pieces of it, some kind of scripting. So you have to understand where is the software coming in. So cataloging the ingestion point is the first step. Once you identify the ingestion points, understand the process of that ingestion, and then start monitoring where the software is coming from, what vendors, what open source, and then start validating the source of that ingestion. And open source, for the open source package, we have OpenSSF scorecard. Navin gave an excellent talk yesterday. That's a good tool. For the vendor, there are some tools. You could use a bit of a static code analysis or source composition analysis tools. There are multiple vendors for that to kind of understand more about the vendor software coming in. Then once you understand that, then you can start actually building controls within your build and deployment pipelines. That includes some of the scanning infrastructure you could do. Obviously, SBOM plays a good role there. But I'm not going to go into obviously this is not talk about vendors or tools or technology, but conceptually the idea is you understanding more about your software practices and where the software is there, that's the key. But that's the half of the problem. The second half is actually where that software is being deployed. So that's where having a accurate and a strong asset inventory is the key for success of the security. That includes all the open source, vendor software, desktop software, anything coming into the firm, start tracking them in this inventory. That will help you when the next Log4 shell hits us, because then it's a matter of then you understand where package is deployed to where and what package is there, then you can have the patching mechanism. Having that asset inventory is a kind of key and center to the whole system. Then obviously there are multiple strategies on how do you secure your internal pipelines, right? There's a source code integrity you could do, which is securing the source code repositories. How do you manage your source committed is not corrupted? Then there's a build integrity, where you can have checks in the pipelines, making sure it's not calling external sources, like air tightening your pipelines. Then there's a build integrity of where the build artifacts are actually being signed and verified. Then there's a deployment integrity. So if you do that, your internal supply chain is secure. I mean, when we talked about the enterprise supply chain, right, there's multiple layers. Some of the strategies are common across everything. Obviously, you have to pick what works based on the processes you have. How are we doing with the time? So, okay, that's good. So let's touch a little bit on the SBOMs. Obviously, we cannot skip SBOMs in any supply chain security presentation. I mean, everyone's gonna love SBOMs. And that's actually an opportunity for me to show some cool chocolates, because it's up after the dinner talk, after the lunch talk, right? So if you look at the Cadbury Dairy Milk chocolate ingredients, so SBOM is very similar to a food label. That's what everyone looks in to start with, right? It's milk, sugar, cocoa butter, vegetable fats, all that stuff, and couple of chemicals there, right? But in reality, the software bill of material is a bit more like this, because in reality, we don't actually have one ingredient, right? We actually bring in a lot of dependencies, and they bring in a lot of dependencies. So when you add that, it's like a box of chocolate. Maybe it's a box of chocolates. That's how the software is in any enterprise. So the list goes on and goes on. And then SBOM is basically a collection of all the software dependencies or components application has, plus the build processes and also any additional data about how the software is being built, right? So that, as you can imagine, is going to go crazy and crazy. So that's why we have few of the standards formats on how do we express the SBOM. There's a SPDX, there's a CycloneDX, there's a Swift tags, which is kind of dying down, so mostly cycle-only X and SPDX are the standard format. But what format you use, it doesn't matter for enterprises. The key is they are kind of interoperable. Most of the cases, you have tooling to do that, but having an SBOM is more important. And then the next step is you get all these SBOMs, and you see it goes really crazy, big. How do we actually operationalize, right? We talked a bit about that asset inventory and have this vulnerability management process work with it. So SBOMs will play a major role there. So if you look at some of the supply chains enterprise I mentioned, the internal supply chain, the open source packages, you could build a SBOM, even if the open source package manager is not giving you. You could look at actually a package builder, you could intercept there and get all the dependencies. You can build a SBOM, right? That's what we do. But for a closed source like a vendor software, it's not that easy. I mean, you could use SCA to guess some of it. That's where actually having an SBOM helps. So it gives a visibility into some of these closed source and vendor products we consume. But once you have that, connecting with the asset inventory is the kind of key. Then integrate with your current vulnerability management processes. That gives you a good visibility into all the dependencies you consume, not just the software you write. And then with that, I'll try to give a bit more, try not to specific to OpenSSF because I'm on their board. So I think which organization you join, it doesn't matter. Most of the working groups in OpenSSF are actually open. You don't need to be a member to be there. I highly advise you to start attending those working groups, involve with them, understand if it works for you, works for you. Otherwise, pick another working group, another organization. The point is, I think, start involving is more important because this is a field, start evolving more. So this is opportunity. If you want to influence, bring in your case, bring in your problems, this is the best time to influencing some of those initiatives being happening. So there's a CNCF tag security group that focuses on supply chain security. OpenSSF I mentioned. We have 6 working groups. There's actually one new one started last year. It's called End User Working Group. So even though you're not a software producer, that group focusing on how do we actually as a consumer can start influencing, we need these elements in SBOM, or we need these toolings to consume SBOM. So there's an opportunity to even start influencing from as an end consumer. And there's obviously a ton of projects, Salsa, SigStore, scorecards. These are all open. Everything is on GitHub. You can start involving to understand about this. Before I close with a few of the thoughts, I'd like to open up for the questions. Sal, you go last. I'll go first with me. Good.
Yes, my question is in connection with the strategy. What I realized that you mentioned at the end is the people, the consumer. Mm-hmm. But you don't think the consumer should start at the beginning? In other words, you build the strategy according what the consumer needs, and therefore build also the consumer integrated in all the process from collection, processing, etc., etc. Because at the end, the consumer are driving the process, not the software. What do you think?
Yeah, so I think I mentioned a couple of consumers, right? I don't know which you're talking about, the end user consumer or consumer being the developers within the firm too. So they're both, I think in my opinion, both are consumer, right? When I said like the strategies on enterprise, right? So most of the developers as a consumer, that's how I think starting with the understanding the software development practices, how they are building the software is actually the key. So most of the processes you're actually trying to secure, understanding those practices will help. With the end user, it's a whole, I think, is a discussion about the usability versus the security there. But I think my focus has been more on like supply chain security to make the security being a transparent and secure, so that I'm not considering more of the end user being in case. Correct me though if I'm going in the right direction. Are you focusing more on end users or the developers? question. Sorry, are you focusing more on the developers or the end users being the?
I'm focusing on end user.
Yeah. End user, like the one actually using the software. Yeah. It's like I think.
It's not so much the software; it's the benefit of the software on the, let's say, on the process.
Yeah.
Because end user is at strategy. There is a strategical, let's say, central place.
Yeah. I mean, most of, as like these are from my examples too, right? Like, if we understand the process of the current, the development practices, embedding security totally makes sense, because most of the earlier approaches where we're trying to make it as a shield, that never worked because of it's so much embedded there. So one thing from my personal experience is like working with the package managers, working with the ingestion process, the vendor management, third party, the departments. Those are the ones usually on the grounds doing some of these like bringing in the secure. So working with them, actually understand their pain point, their friction points, automating some of them is actually the key for success. So to your point, yes, we consider that from the beginning. Go ahead.
If a country like the UK or the US were to impose SBOMs to enterprises now, or let's say your enterprise or your company, would you be able to provide the SBOMs straight away? And if not, what would be missing? What would you need right now to be able to meet this requirement?
Yeah. So to be clear, I'm not supposed to talk about JPMC. That's how I got the legal permission to talk here. It's not talk about JPMC practices. I'll keep it a generic answer, right? Currently, it's not that straightforward, I think, generate SBOM for everything you do, right? But if you have a modern tech stack where you know like all the software being generated, the points, the package managers currently do allow you to generate the programmatically SBOM. So for the companies, I think, where they have a good handle on the development process, actually it's a straightforward option. But for, I think, for enterprises where actually they have maybe a different and some customary practices where then they have to do some work to generate that SBOM. But there are tooling available to do that. There are two questions there, and Sal.
Right. Sorry, quick question.
Oh, Abdullah.
Do you see challenges with transitive dependencies?
Yes. I think I briefly mentioned, right, like the SBOM for that box of chocolates itself is actually is hard to fill in a page. But when you look at any large to like a medium to large software, actually SBOM kind of really creeps out, mainly because of the transitive dependencies. So one of the evolving standard from NIST in USA is the VEX, which is the Vulnerability Exploitability Exchange. Actually, I do have a lot of high hopes on it. That is trying to understand whether actually a specific dependency, transitive dependency, have an impact or not, rather than we're trying to patch every transitive dependency. Because in reality, if we operationalize like as it is, I think the VM team going to go crazy. They're going to actually not going to do it, because every minute you have a CVE to fix, which is not going to work, right? So VEX is the other one. There are few innovations happening on even understanding, go deeper into the actual call graphs to understand whether you have been using the specific transitive dependency, the part which is actually being impacted, have impact in your software, but I think there's a bit more research to be done there.
Do you think that, obviously, while SBOMs have, so to speak, taken off, do you think that that has caused somewhat of a race for organizations like JPMC to themselves start consuming and in some cases producing SBOMs? But do you think that's leading to the production of incomplete SBOMs that don't tell the true picture of what it is that the application is and what they're consuming? And do you think that in some ways the SBOM actually causes a safety blanket in the sense that they think that they know what's in it when in actual fact it's actually quite far from the truth? Have you done anything in that area to understand that more and see where the problems could lie?
Yeah, I think if I'm understanding your question correctly, it's as I mentioned, like if you take, again, not JPMC, take any big enterprise, we have to deal with like a lot of vendors, right? Hundreds of vendors. So not all of them are ready to give SBOMs. But one of the initiatives we actually trying to work with the third-party vendor procurement process is actually making SBOM be one of the required elements going forward, right? It's not done yet, it's been work, because obviously we had to work with the vendors that we have more control over. So part of your question is obviously, yes, we are involving with trying to get SBOMs from the vendors we use. We don't directly sell products to everyone. Obviously, we are more of consumers. So to your other part of questions, like do we able to produce SBOM? For all internal software we do have an option, but that's not that, because we don't actually directly sell products to other people. I think the third part of question is like, how do you validate the accuracy of SBOM? I think that was your question, right? Yeah, I mean, obviously that itself is a unsolved problem, but in my opinion, there are multiple ways we can go after, right? I think getting SBOM itself is a big improvement from the current process. Current process is actually a point in time due diligence we do on, hey, what is your practices? Are you good, right? And then you don't do that for next X months. So getting an SBOM at least is a dynamic way. Then second thing is obviously there are some tools you could do, like a binary analysis to get a baseline of, okay, I'm seeing these and your SBOM has none of them. What's the point? Like we could even do some kind of baseline. Obviously the binary analysis doesn't give you a full picture of a closed source, but you can at least consider, like, is it close enough that it gives you, are they going in the right direction or not? I mean, again, it's a contractual legal binding, so you have the vendor to do that. But eventually, in my personally, it's not JPMC view, I think the way we're going to solve this is some kind of a third-party validation service, not one, maybe multiple, which kind of say that attestation. So the whole attestation of the SBOMs itself is, I think, is a evolving subject.
Hey, Thomas Steenbergen. Not really a question, but more a remark. For the people that have questions about SBOMs and VACs, I actually work on that. I work on the SPX security profile, I work on VACs. I actually have a talk in about 45 minutes where I actually will demo how you can do SBOMs with open source tooling, and also how I actually left out some of the technical details that are now being asked about SBOM validation and all that stuff, but people ask about adoption. There's actually under LF open source tooling being developed, actually originally developed by German Automotive that are really a little bit in front. So there is actually open source tooling to generate SBOMs, to do all of that work already out there. It's just probably unknown. So if people are interested in that, you can ask me things now. You can also see my talk in 45 minutes.
I was about to say, all SBOM questions, actually, Thomas going to give a talk in half an hour. Back to Sal.
So what you're describing for your SBOM practices is like pretty, like genuinely best practice, right? Verify it, sign it, do it with your CI/CD so that you're not missing anything to the best of your ability. But let's reflect a little bit on this idea that like it's several different chocolates in the box. And unfortunately, when I was doing Security Slam a few months ago, inside of CNCF, there was only a single project out of 128 that even had an SBOM when we started that. A couple more do now, but not a single open source project has a fully automated way to deliver their SBOMs. So at this time, making sure that we get that problem fixed and making sure that it's not just a massive amount of regulation-driven developer toil would be really nice. The one other aspect of this is that you've got like the perfect use case and architecture for the way that like SPDX has been designed for right now. It's been designed for cloud systems. Now, I have made a bunch of new friends because we all try to build our own SBOMs for industries outside of that, and we can't. And so we're all bonding together over the developer deficit of good documentation around this. And specifically for anything ranging from like single board computers to what I do, which is AI ML pipelines, we've not built that out yet. And that's just a major concern for me.
Yeah. I think that's where probably Thomas Talk will answer some of it, go into deep it. But I mean, SBOM, when NTIA proposed 2 years back, I think even they were trying to figure out what this is the minimal element we actually need in SBOM, right? So it's only 2-year-old, so it's a very new, it's actually a very evolving form. But we all know that it's important, gives a good visibility. It is a kind of foundation for our trying to get inventory all our dependencies. But again, I think it's an area I think we all need to actually start contributing because there's so much to be done. That's the reason we're trying to form, actually working with the NTA and government on financial sector SBOM pilot to see, hey, what are the additional elements we need from a financial sector rather than just depending on general SBOM too. So because energy sector is doing in USA, I would highly encourage, like, is there any sector like you're part of, like maybe there's additional stuff you need. This is a good time to be involved. Our time? All right, let's do the closing thoughts. The sad truth is there is no magic switch to make the supply chain security secure. Also, there is no single vendor, whoever is claimed to be, to solve this problem, right? The only way to do is you need to understand more about your software development practices. You need to more understand where the software is coming into the form, where it is going. Having that good understanding is the only way. And then on top of it, SBOM, use these great projects, open source projects coming there. Then that's the only way we could get to a position where maybe at least we can have some sleep when the next Log4 shell hits us. So good luck. Thank you. So if you want to reach out to me, obviously, LinkedIn is the best option, RAOL. Thank you.
All right. Momentarily, we are going to take a step away from big supply chain thinking and jump all the way inside of the kernel, which is very exciting. So please welcome to the stage Alessandro, who's going to talk to us about eBPF.
Hey. Yes. All right. Hey, thank you for joining this session. Yes, a bit of a break from the S-bond security. I don't know why this talk is in the security track, but hey, we are here, and there is actually something about security that concerns eBPF, so we'll talk about it in a bit. So, first of all, I am Alessandro, so I'm here on behalf of my esteemed colleague Rohit, because Rohit couldn't make it because of visa problems, so he asked me to step in and be here on his behalf. So I would like to introduce you to Rohit. He's a developer advocate at Solo.io, a company that I just joined. And he's a very enthusiastic guy, and I'm so sorry that he couldn't be here, and I feel like we owe him because he was really excited to be here, but unfortunately there was some problem with the visa and he couldn't make it, so hopefully maybe next time. So this is Rohit. He's very active, he has a bunch of communities, he's very enthusiastic about this DevRel thing, and he's really, you should check him. He runs this community where you can share your experience about developer relations, and it's just a very, very cool guy. And because we co-present, so he should physically be here, but he can't, so I have some parts where I'm gonna talk. I'm gonna talk about the eBPF, of course, and some parts he recorded some videos for us, and then I'll show it to you, but I'm here to answer any question if there's any doubts, or you can check with me later. That's me instead, so I'm just a very fresh developer advocate. I just joined Solo a couple of months ago, so I'm really excited to start talking in public more and more, and I'm also organizing the Dutch Kubernetes meetup, so I'm a CNCF ambassador, although CNCF ambassadors are no more, so I used to be, and I run the Dutch, of course, the community, and also the KCD, the Kubernetes Community Day at Amsterdam, which is a very interesting conference. It's happening in 2 weeks. So again, if you like to visit Amsterdam, if you want to engage with the Dutch community, ping me or talk to me. We love to have people over, and maybe one day we'll have something like this, but in the Netherlands. It's my dream. So I work at Solo.io. It's a very, very dynamic young company. It's a startup. We are about 200 people, but we are really all focused on service mesh. So we are the company behind Glue, which is an enterprise version of Istio, and we extend it with multi-cluster and federation and all sorts of magic stuff that I'll be very happy to discuss with you. This is not the focus of today, but definitely something that we can discuss. And yes, we are hiring, of course, still, even in this climate. But also, because we are so concerned with application networking, and we do quite a lot with enhancing what programs can do in a cloud-native environment, right? So at some point, we also encounter eBPF, right? So we look at Cilium, and of course, like everything I'm saying today, I saw that, of course, before me, yesterday there was the great talk from Liz, and I mean, she wrote the book on eBPF, and she's great, and of course, I hope you were following that talk, so you got some introduction to eBPF. I'm not gonna go through the whole story. Of course, eBPF is a very large topic. There are even books written about it. It's been around for quite a long time. So I'm just going to show you what we did at Solo to make you write eBPF program a bit easier, right? So something a bit more streamlined, we improve the user experience, so to say. So eBPF, I'm 46. I was there when Linux was released. I wasn't there in 1992. I was just a kid. But I remember when eBPF was released in 2014. And so I remember there was this movement of enhancing the original Berkeley packet filter, which was born just to intercept network calls and program, do something with it, with eBPF, right, with the extended Berkeley packet filter in 2014. So what it is, it's a way to work with the kernel in a sandbox environment, so without really decreasing the security or be more secure in interacting with the kernel. And it's a way to run programs that can interact with the kernel space in user space. And so you can be very close to the kernel in terms of performance and in terms of what you can see from the kernel, but still keep it very, very safe and very isolated from the rest of the programs running on the same kernel. So there's a foundation around it, so it's so important. It's an important piece of modern networking, base of Cilium and base of many other tools out there, which, well, we're going to talk about one specific tool, which is Bumblebee. So what it is, it's a way to execute this custom logic, custom programs in the Linux kernel without affecting the whole machine, the whole host. So it works with hooks, right? So we hook into the Linux kernel to the eBPF, and we collect data, and then we store the data in some specific data structures, hash maps, ring buffers. We'll talk about it, and we use that data later in a user space program. So it's a way to extract information from the kernel and do something with it, right? So this is, and also you can write back to the kernel. You can modify or do some packet processing or applying policies at the kernel level. So it's extremely performant and it's very convenient because everyone runs a Linux kernel. So that's exactly where you want to operate when you want to have performance and security. So use cases, of course, security. So intercepting syscalls is the base of many security tools like sysdig, Falco, and other ones, where you can see what's going on, intercept, because everything has to be a syscall in Linux, right? So everything has to go through the kernel to interact with the network stack or with the disk, with the I/O stack, right? So syscalls are where you can plug in and see what's going on, right? So, and that's exactly what eBPF can do. It gives you a hook where you can collect data and work the security of the system. So you can see which process writes which file and be alerted when something happens. There's a whole security plethora of tools around eBPF. So traceability profiling is very close use case. Of course, you can see if a process is consuming too much or what the consumption of a process can be. Networking, very important, so you can see everything that goes through the kernel, everything that goes through the network stack of the kernel, so you can see who calls who, you can see the packet drops and so on. Everything that is coming from the network stack, the network interface, you can collect from with eBPF programs. It's really just very powerful way to have a very deep overview on what's going on a host. Of course, also, and that's the topic we're going to talk about, it's observability and monitoring. So getting all this data, export them somehow into a format that we all understand. In this case, we're going to show that you can use Prometheus metrics format, and then collect them and show them to your users. So the high-level architecture, of course, you all start from the kernel. So the kernel is what runs on the host, is the interface between the user space and the hardware underlying. Sure, this is most of the time a Linux host, but surely Microsoft engineers and others that work on porting eBPF to Windows. So this is not only a Linux-only game today. There's also a way to run it in Windows. It's in development, but it's something that it's important because then you have one unified way to look at kernels, no matter if they are Linux or Windows. So this is how it works. So you write a eBPF program that interface with the kernel runtime, and then it shows you or exports this data up to your tool, in this case, for example, Cilium, Falco, and the one we're going to talk about today, which is Bumblebee. So this is, again, so it's not I'm not going to give you the whole story about the BPF. It's people better than me, of course, talk about it. But in general, like you write a user program that is always verified by the kernel. So there's a hook that verifies if your program is safe to execute, and then execute these hooks like K-probes, U-probes, and trace points where you can collect the data and then send it back through these maps that we talk about. So let's say that you want to write a eBPF program, and you have a few choices. So the first choice, the one that most people start with, of course, is the BPF compiler collection, which is a Python wrapper around your BPF programs. It works. It's just a bit clunky. Of course, you have to know Python. You have to embed your eBPF program inside as a text file, as a text structure into your Python code. So it's not exactly the best user experience out there. And we'll show in a second why it's not that great. So, of course, you also need a lot of extra stuff, kernel headers, Python, knowledge of Python. So you have to write your user space and your kernel program together. So it's a bit, it requires a bit more steps than what we would like to do, right? So, and it compiles, and it creates this binary that can be executed. So the next step, which we'll show you in a second, is to use libbpf, which is has introduced this concept of compile once, run everywhere. So where you compile a program that can be run anywhere you want. So you compile it, you can port it to another host and run it there. So it's a bit more portable. It gives you a bit more flexibility in what you need to provide to compile the program. So, but you know, like a demo runs, it explains much better. So this is Rohit, and I want him to be
After that,
virtually here.
let's start with today's demo, where we are not going to do any different kind of a thing, but here just I will show you like how the Python code and your how the code is TCP connect, which you use like TCP dump in your laptop, right? So where you see the IPs and addresses once the TCP dump is used. So here we are when it was a BPF compiler collection code. So what happens? You have to write it in Python and C kind of a thing. So here we are just using the TCP connect file where we are running the same thing and we are getting the output like various websites running on my laptop system. So similarly, as you see, there is source and destination IP address for all communications. So let's see what is going on inside that file. So here you can see the beauty of the program. So here, as you can see, there is a C language code is written here. Yeah, see. Till here you can see like C language code is written, but it is really complex and really tough. Like I'm not that much expert kind of thing, right? So after that there is Python level code also, right? So when you are writing the two codes in the one program, there is like different issues you can face because C program is embedded into the Python code. So what happens during this stuff, you can see the program is small, but it's not easy to understand. It relies on various naming conventions. And when there is a various naming convention, you know like what can happen because you have to target it to various things and trace it and stuff. So yeah. So second part is like user space program, which we discussed at the top below. So BCC works, but it has a lot of limitations, as we told, like heavy resource utilization and dependencies on kernel headers, which we have to track it and kind of thing. There is a really complex debugging here. So what can we do? So why the eBPF is trendiest, and why it was discussed a lot during last year's, right? Last KubeCon and stuff. So to overcome these limitations, libpf and BPF core took a different approach. What they did, so now you can write entire code in just a C language. You don't have to write the different code, and that C language code is written in such a manner like you can compile once and you can run anywhere. So to show that, we will just move to the different directory, and these files are available, right? Here you can go and you can check that files. So after that, you can copy these files, and we just have to make. So if you are from the sysadmin and DevOps background, you should know like what happens when we do the make. It will generate, it will combine the files, and it will make compilation. So once that is done, we will just use that TCP connect to run, and you can see the similar output, whatever IP and destination IPs were running in my system, it will reflect. So it is so nice, right? So I don't want to waste your time, and I will directly show you what it goes inside that BPF core. So as you can see, everything is running in the C language code now. So such a beauty, right? As you can see here, like we have the one thing you should notice, like it is everything in the struct. So after that, I will also show you. Yeah, that I will show you by the command. But struct, as you can see, here is the first interesting part. This defines a BPF map of type hash map. So here you should see that max entries 1 here only. So yeah. So as you can see, there are two main types of maps available, which you know, like ring buffer and hash maps. But we are using the hash maps in here to store data and some key references, because it does not function as a queue. So it has a traditional map where you can map your keys and values however you want, and it will be there until you remove it. So another section to discuss is that kprop. So this is like everyone asks like what is kprop and that kind of thing. So you can go and learn it deep wise, like what happens. It is nothing, just it is one kind of a thing where you can connect the eBPF with the your TCP and networking layers. So as you can see, this defines a kprop that will attach to the TCP connect. And let's look out to the source code of the user space application. So you can also view that, and inside that you will see like there is some print count IPv4 function. Yeah, here, and inside that, as you can see, there is different source address, and that key value mapping is not kind of thing, but yeah. Other than that, you can see how the user space application gets its data from the eBPF program. So we are just assigning that values taken from the previous and assigning here. So, and you can simply copy the TCP connect binary and execute it on any other machine. So once you get that binary file, you can take it and use it anywhere you want. So that's why it is like compile once and run everywhere. So what if we could only write the BPF program, right? It will be really beautiful kind of thing, right? So let's go ahead and move to our next.
All right, so as you saw, the first one with BCC, you have to do Python and then execute your user space program, and of course with libBPF you can compile and it works just fine. Okay, so now we want to improve the user experience, right? So I don't want to write complicated user space programs. I want to just focus on the kernel side, on the eBPF program. So that's why we, as Solo, they came out with this Bumblebee project, which was an internal tool that then they decided to open source, and then to simplify the building of these programs and the management of this eBPF program. So the idea of Bumblebee is that you use it like you use Docker. You do Bumblebee build, Bumblebee B, which is the command line, push, so it generates OCI compliant images that contains your program, and then you do brun to run your program. And you also have binit, which scaffolds your project. So it's pretty convenient, and if you can think of these eBPF programs like you think of Docker images as OCI compliant, then it becomes much easier. You can just push them to any registry and let somebody else pull it and run it. So that's exactly what this project aims to achieve. So, and there's another demo. Sorry, it's a shorter one.
So you can get it from the open source GitHub repository also, but here we will just run that command similar to that. Use the export whichever terminal you want. Once that is done, as you can see, we will do the binit like Terraform init, and it will initialize everything. So it is in the C language, but we are planning to make it in the more languages like Rust. After that, we will go with the network type for this initialization. After that, we are using the hash map because as we discussed, like we want more convenient kind of a thing. So after that, we will go with the print, I guess. Let me check also. Yeah. So we have to just mention this probe.c program file location. Once that is done, you can directly visualize what generated and kind of thing. Right. Sorry. So let's do the cat probe.c, and then you can see it's inside that. So as you can see, everything is there, and now I will show you the beautiful part. Like everywhere there is a counter. So what is a counter, right? So here you can check, like we will use the diff to see the differences between the your say TCP connect and Bumblebee code, right? So there is just a counter. So it is using that counter to suffix to let Bumblebee know like how to interpret it on the user space. So it is really beautiful, right? So let's copy the updated version. After that, we will build it like a Docker. We will build it, and you will see like it has the same naming conventions kind of a thing. It is using the local host and so IP kind of a thing, and then image name and version like tag. It is really easy way we have created. It's like it is built on the open source, so you can use it anytime. So as you can see, yeah, we have just pushed it, and now we can run it however we want. You can see here. So once it is running, let's do the curl to check the metrics. You can see like metrics are generated because the traffic is creating here, and it is increasing the values, hash values and stuff. So as you can see, Bumblebee also provides metrics in the Prometheus formats. So we already generated that, and now you can use this Prometheus metrics wherever you want, right? Really convenient kind of a thing. So
okay, so if you see binit gives you this initial program that you can just use for your to start a project, and it's quite convenient, right? So you can use it to quickly put together a eBPF program. And you see, so there is actually on this machine. By the way, these labs are on academy.so.io, so they're free, they're based on Instruct. So in the Instruct virtual machine, there is actually a Docker registry running as a Docker process, so that's why the Docker push localhost. But you see, it's like exactly what I said. It's you build this, you compile, and you build this eBPF program in a OCI registry compliant image, and then you push it and you run it. So that's very simple. So where you go from there, of course, this is Kubernetes observability with eBPF. So let's see how you integrate this actually with Kubernetes, right? So how do you run this in your cluster? So this is what we're gonna create, more or less. Again, these all instructions are available. So we're gonna deploy a demo application and then a daemon set that will run exactly the same program that we built, but this time as a daemon set on every node. So because it runs on every node, you can clearly gather and collect all these Prometheus metrics and show it. We also build this KeBPF, which is a visualization tool for eBPF. So this is the last one, so that's good because we got 5 minutes. This is 3 minutes, so that's great.
As whatever I told you, so let's apply that application, sample book info application. After that, we will see like pods is running or not. It is containers are creating, everything slowly. So everything is not on the same nodes, different nodes are there. And after that, we will just create the namespace as a Prometheus. Prometheus namespace is created. Every time I recommend everyone to create the environment and namespace every time you are working in the cloud native world. So after that, we are just using the Helm charts to add the Prometheus. So it is available in the GitHub repository for the Prometheus only also, right? You can use from that. So what this code is about. So we have created a Docker image with a Bumblebee. We will run it in each Kubernetes node to load our TCP connect eBPF program and gather the information about all communications happening in the cluster. So it is just like getting the metrics, how your application is interacting with the eBPF kind. So let's do that thing. We have created our demo set app only. With that,
let me just grab your attention on the, you see, so this Docker image contains the B executable, and as a parameters, you point to the local registry, is on the master node, of course. So the image will pull the eBPF program from the registry and run it on every node. So the image that we built is not a Docker image, just an OCI image that contains the eBPF program, while this is a Docker image that contains the B executable. Okay, so let's keep it to where we were.
With that, so remember, like master is the host name for our VM where the registry is running. So as you see, pod monitoring ports have been created. So let's generate some traffic to see the beautiful things afterwards, right? So it will show you, yeah, it is creating. So we now have all the metrics captured by our eBPF program and stored in the Prometheus, like we generated last time, right? So same thing we will do, but source IP address corresponded to the pod IP address and destination IP address correspond to the server cluster IP address. So that kind of application we will create now using the KeBPF to gather the metrics from Prometheus, and we will see the dashboard also, right? So we will first create the RBAC kind of thing, cluster role binding. So as you see, cluster role binding is created, authorized, and we can now deploy our KeBPF. Yeah, service account is created, deployment apps, service are created. And now, as the diagram below shows how all the components work together, as I discussed here. So here you can see this thing we have done now, and this is the interaction. So let's see like we have created or not. And these codes are available, right? You can take it from here, you can copy paste and this thing. This workshop is also available on our Solo Academy. You can go check it there. So let's see what is generated. Yeah, as you can see, beautiful dashboards is here. You can play with it, you can do various things, and you can see like Prometheus metrics are generated from here, and there is a metrics server, and similarly as you can see your product page, your reviews, ratings, and that kind of thing. And this was the left part in our diagram here. This is that, and this is right one. So really beautiful, right? I guess I solved your doubts, and really glad to see that. So yeah, we have next things coming up.
Okay, so this is exactly what we aim to build, like a observability stack built with just a few lines of code and just a few things running on your, and a daemon set running on your node. What's next? Of course, an operator to facilitate the whole deployment, support for Rust and Golang is in the works. And of course, like you can join our Slack where we can discuss these things. There's a Bumblebee channel there. We just opened an ambassador program for Solo.io, so please, if you want to be part of the fun, you can join. You can come to talk to me. Solo Academy, academy.solo.io. You can find this and many more of these tutorials, so you can just follow them and see for yourself. And thank you very much. And if there is any question, I'm here for everybody. Thank you.
That work saves my developer team on average like 2 or 3 weeks of time, so
Yes.
thank you.
Thank you.
Right now, we've got a bit of a break, but make sure to be back here in this room exactly spot on 4 p.m., where we will solve the SBOM problem once and for all. Wow. We're live. All right. Welcome back to the end of the security track for State of Open. Right now, Thomas is going to tell us all about SBOMs and how easy you've made it for us all.
Easy. Things are never easy. All right, guys. Or folks, better say my folks. My name is Thomas Steenbergen. I run the Open Source Program Office at EPAM. Just to show and find, so how many people are familiar when I talk about an Open Source Program Office, what it is? Not so many. So an Open Source Program Office is your kind of your knowledge center in an organization regarding to open source. As you can see here, I'm involved in a lot of projects. I sometimes actually get asked, like, do I work for the Linux Foundation? Because all of these are Linux Foundation projects. Almost, actually, the Bitkom not. No, I just have an awesome company that actually understands open source. And we figured out how I can do all of these contributions and do all of this open source. But it will become clear why I'm involved with all of this stuff. This is a very pretty picture of kind of the first kind of compliance workflow that I up. Actually, the first version was actually on a beer napkin in a beer garden. If you ever come to Berlin, give me a ping. I know some nice beer gardens where you have some beers. So this is the pretty up version of how a workflow normally looks like, where you start with a code change, then you have the scanner, and there's okay, not okay, and if it's okay, you can release, and you have your SBOMs, you have all of those things. If it's not okay, you have to usually do kind of curation. So you have to do either license curation or security curation, and then you fix things up. So they're very simple workflow. And of course, then I looked on, okay, I need to get some tool. And of course, my friendly sales rep from my SDN defender says, yeah, sure, don't worry, we can all automate that. But I actually am an open source guy, a long-term open source guy. And nowadays, we all talk about supply chain security. I already realized, like, if I, as an open source guy, buy proprietary software to do open source reviews, this doesn't really sit right with me. Like, we should really do something else, especially since we have all this history. But if you think about it, right, my open source challenges that I have in my organization are probably not many different than what you have. I might have some internal politics that's different than yours, but doesn't matter. What we really should be doing is basically collaborate together and try to fix things upstream. That said, I don't know if people are familiar with this blog post. It's actually a very nice one. It's from an open source maintainer, and I very much agree with him because I am also an open source maintainer. Look up the list. It's Santopal-Jean-Pierre, and basically he makes the argument validly, like, hey, I'm a maintainer. I give out things for free, but my license has a good statement that says it's as is, a big disclaimer. It's like, hey, I give you code for free. Don't come back to me if there's anything wrong with it. I'm giving you stuff for free. This is the same that I'm putting here 20 free pizzas on this desk. And one of you eats the pizza and they get sick, they get food poisoning. Doesn't mean that I'm responsible. No, I have been baking my ass off. I'm baking 20 pizzas right here, all for free. And I'm giving them away for free. I'm an open source maintainer. So just a friendly message, and I'm a maintainer myself. I really work day and night till 2, 4 a.m. at night to help out my users. I'm generally a very friendly guy. But don't treat us as a vendor, please. Treat us as a maintainer, as somebody that's your friend, and treat them with the same respect you pay to your friends, or as my other friend always says, treat it with the same respect as you would treat your mother. So my question as an OSPO, actually, where I was looking at, okay, I need to do things at scale, at speed. For the people that don't know EPAM, we have 55,000 software engineers. So we have everything under the sun. We need to do things safe. We want to respect licenses. And we also want to do sustainability. It's not fine that we just consume. If we don't do things sustainable, basically, these projects upstream that we rely on die. And then we have a problem. So, and of course, whilst we're all doing this, I need to keep my devs happy, right? I cannot put something that will make the lawyers very happy, will make my security guys very happy, but my devs will be crying. So, years back, before we had all of this fancy things, this back in 2015, I came up with a plan. It's like, I want to do more open source. I'm just gonna, since I'm a long time in the OSPO stock, I'm just gonna build open source tooling that's gonna address the challenges of OSPOs. Then I'm gonna open source it. Then I'm gonna collaborate with all of these OSPOs, which generally are big companies. They have money and they have resources. So they're gonna improve this tooling because it actually solves problems. Again, it's a users building tools for users. And then we're gonna add other stuff like security, inner source, coming out, and all the other stuff. And then once we have done this, basically this whole security compliance stuff, this is normally a lead ball for OSPOs. It's like, oh, crap. It's usually what a lot of OSPOs get stuck into. Well, I make this easier for all of the OSPOs out there. So what do they then have more time for? For contributing back. And if they all contribute back, they use all of those resources, they can help make projects more sustainable. And then we have this vicious cycle. The more they contribute back, the more everything is better. And I was like, yeah, that sounds like a good plan. So, Sal, it's not my 2030 plan. I did this back in 2015. So my goal actually, when I was looking at this, we were building, I was like, we can build a tooling in 2 years. We should be done in another 5 years. And at least it will solve the whole problem. It will make the thing better. Yeah, that was 2015. It was a little bit naive. So this also explains, I now listed all of the projects that I'm kind of involved in. I had to fix things all over the place. From really like, oh, hang on, I need to know how to basically do contributions at scale. Let me go to do. I used to work for a company that was in the automotive side. I need to have an exchange mechanism. Before it was even called SBOMs, I was involved in SPDX, now it's all held SBOMs. Then I was like, oh, I need to fix things inside my organization. I need to teach my organization about how to use open source. We go inner source. And well, more recently, when we had the founding of OpenSSF, now I'm also involved in OpenSF, of course, because I was doing all the other things. So if people have any questions about SPDX, CycloneDX, or VEX, I'm involved with a lot of those things. And finally, which is where I actually thought the gap was the tooling. So what OSPOs need is something that addresses their problem. It's nice that we have all of these little tools out there, but what they actually want, they want an end-to-end workflow. They want something that they can just roll out, is trusted, has been done by others, and so that works for us. And we couldn't find anything, so we just built it. Literally, we were pissed off users that were not getting served. So what do you do when you can't get what you actually need to solve your problem? So you have people like me that are like, screw this, we're just going to build it. And I happen to work for a company that allows that. So this is what we built, OSS Review Toolkit. As I said, this is built by users, for users. It's mostly now automotive OSPOs, but we also have some folks from the energy sector. We have some telecom. Now we get some more banking users. For instance, the Eclipse Foundation has recently decided to basically use ORT as their basically the foundation for all the supply chain, and we're now working with Finos to do the same. So again, go and fix things upstream. We built the tooling. Yes, it was originally built for enterprise users, but when we built it, we kept in mind it needs to go upstream. So we made it friendly for upstream. Then what we also did, I was like, we built the tooling, but yeah, we want a turnkey. So why don't we just open source the data and the policies as well? So if a new OSPO comes around, here you go. Here you have everything you need to get started. Because literally, we don't care. For us, managing these things, this is not the core IP business of all the companies involved. It's just the tooling, things that we need to get better at open source. There's no core IP in there, so we just open sourced it. We do a lot of things, and I'll go quickly since I don't know how much time we left. So we do licensing checks. That's where we originally started. Then we started doing security. And whilst we were doing this, actually all these things have common overlap. We can actually do inner source as well, and Waze is working as well. But people ask me, like, what is Waze working? Actually, it's very simple. You have a large company, using open source build tools, and what if you want to make sure that all the packages you build use your namespace and use your approved company license? So this is actually a major problem where there's really no tooling about. We want to make sure that, yes, we want to enable this open source, but at the end, it's an organization. You want things to work end to end. So this is where we build in mechanisms. So it's like, yeah, it's fine. You can use whatever you want. We want to enable all of the developers, but your package has to be in this namespace. Your package has to be in this internal used Git. So that's also another problem that we fixed. We were doing migrations. And we were like, hang on, we can just program this in a tool. If people are using now the old, we're using an old Nokia system at the time, we can just add a rule and say, like, if you're using an old Nokia system, you have 90 days to migrate to our new GitLab instance. Because we were scanning their code anyways, so we knew exactly what we were about. And finally, well, the thing that I'm really now loving, software bill of materials, because I was working in the automotive business, and we had a supply chain problem. For people that don't know how automotive or how cars are built, it's a huge supply chains. And you have this kind of hamburger models where we would have a supplier to us, we would do some software, then it would be another supplier, and then we would back again. And how do you make this entire supply chain work? And I have to give credit to Endo-san from Toyota. And when I was talking to him in Japan, it's like, yeah, well, if we have some open source solution, we can make this easy. We need to have this end-to-end. And then we cannot force our suppliers to buy commercial tools. But yeah, if you have someone good, we can always recommend them. And that's especially useful because I was I'm based in Berlin, Germany. But most people don't know that your automotive part suppliers, these might be family-run companies that have like 150 employees or sometimes even 30 employees. And that may be the company that's making the little clicker to open up your car. So it's not all big companies. There are tiny specialized suppliers that maybe don't have the resources to build an SBOM solution or build an SEA solution. It simply doesn't make sense. So if you want to get started, it's actually really simple. We have a GitHub action, and it will give you an SBOM. So simple, problem solved, easy. Yeah, not entirely. Just because a tool is capable of generating SBOM doesn't mean that it's actually of a good quality. You have to understand, and at the lowest level, we're dealing with build tools. So ORT support 20 plus different build tools. Those build tools have a lot of ways to be configured. And a lot of the data, the metadata for packages, is incorrect. So just because you can produce an SBOM doesn't mean it's a high-quality SBOM. So we need to build in mechanisms for licensing and all the metadata that makes you say, like, yeah, the package says that its code repository is there, but actually we know that the code repository has moved, so it's there. So why do we do this? Well, in the workflow, the thinking was very simple. We want to do licensing, security, etc. We need to resolve everything back to the corresponding source code. Because if you have the corresponding source code, we can do licensing checks. But for us, also important, in the automotive business, cars are on the road for 10 plus years. If you look at the legal things, we have to have the source code for 25 years. So my successor at my previous employer still needs to have access to that. So we need to have the source code. But then I was also thinking, if we have the source code, we can do all of these open source tools. They also run often on the source code. We already have the source code. So that's all these nice benefits. So just keep in mind, just because your tool produces an SBOM, it might not be an accurate one. Going back to the inner source model, so going back to the simple diagram, I was like, all of these tools, they always are like shift left, oh yeah, cool, cool, cool. But they put all of this effort on the development team. I was like, oh, that's nice. Coming back from a licensing background, I can tell you what most developers know about licensing is wrong. And I don't want to burden my developers with a lot of these things. In our previous talks when I do I always compare developers and lawyers to cats and dogs. They can live in the same house, but they don't speak the same language. I don't know exactly if it's true for security folks as well, but I've been in both worlds. I can tell you that the licensing folks and the security works are maybe part of the same open source community, but they're a different type of folks. So I was just thinking, hang on, we do all this shift left. I want to enable a workflow that we, as an organization, we probably use the same open source throughout all of this organization. Why don't we figure out a way that we can do this in an inner source way? So we do license clear and security clear together as an organization. And then I was like, hang on, but if we can do it inside the organization, we can also do it with the community. Wouldn't it be nice if somebody else does your license and security clearance because they already looked at the package? And it would be especially helpful if it was the upstream maintainer that says, like, actually, this vulnerability is not applicable. Wouldn't that be nice? So we were looking at this, and we're like, we fixed it internally. You know what we do? When we throw a policy violation, so in order it's possible to have we have a policy engine, I will show it a little bit about it. You can write, this security vulnerability needs to get fixed because the vulnerability is this, or this licensing problem, you need to clear up this stuff. So I actually put up an example for the licensing one because of technical difficulties. I had to not be able to do a live demo, but I luckily had a screenshot of this. So what we do is we give instructions to our developers how to do this. And we do this in a language that the developers understand, reusing developer systems. So we don't send them off to some web server, web application where they don't know. We just tell them, like, look, you probably know where this software package comes from. Use this little YAML file at the location and submit it via a pull request or merge request to the open source program office. We will review it and then we'll merge it. We have a complete end-to-end traceability where this curation, as we call this, comes from. And then, basically, we can merge this, and it goes to all of the other teams. In the beginning, I can tell you when we rolled this out, the developers were giving us garbage. Really, 90% was garbage. But after a while, and when we did a little bit of education and we explained to them, like, actually, this is an open source project, if there's any bugs, we are fully open source. Like, I run my OSPOs the open source way. Why? It was very simple. I, as an OSPO, need to advise my organization about open source and all my other staff members as well. If we're all involved in an open source project, all of my people will learn the ways of working in the open source community, which is perfect. And now we do exactly the same. To my developers that I need to get more developer friendly, hey, we use open source tooling to do the checks that we're legally required to do. Oh, there is a bug, we don't recognize this Python dependency. Oh, you're actually a Python expert. Can you just go to our GitHub repository, file an issue? That's the minimum I ask. Minimum, file an issue. The funny thing is, after a while, people start to learn. So what they sent to us as basically bug fixes became better and better. To in the high 90% was accurate. We got also more developers like, hey, I like this problem. You're actually not buying proprietary tooling that I always hate when my previous employer. You actually do open source stuff. And when you explain, oh, this is cool, I'm going to contribute. So slowly, things get better. So I still a little bit about policy as code. So we have a public code repository where we just literally share, here you have the data, here you have the policy. And I put in a little example. So a lot of tools you can write, like it's all UI and all the other stuff. For the things that we want to do, I need to take into account the product context, the code context, the license context, the security context. I have an algorithmic formula, whether it's thumbs up or thumbs down. And yeah, I'm from origin a software engineer. And the people that are working, so why? We don't lock down. If my lawyer or my security professional says this, I want to be able to just translate it into if and else statements. That's how we started. And then for this is a little bit of, so we started writing helper functions. And that's how we come to functions like this, which is actually really, we just write a rule. And then we have these require blocks that basically say, oh, if it's a project, it means it's in the root of the project. If it's not excluded, so that actually it's shipped to the customer. If it has a vulnerability with this vulnerability score, then do that. So what we do is we do what we call this policy as code. And this enables me to do whatever my organization wants to do. I can probably write it in code. And when my developers have a question, I just basically say, like, well, this is our code repository, here's our policy. So they don't have to go to a 400-page wiki page. No, in the scan report, they get exactly the instructions, how they can fix their issue. And if they're like, oh, why did it violate? They can even read the rules. It's just all code. Read the bloody code, right? That's what developers do. And then, fine enough, we're like, okay, then I was involved for SPDX Live. Okay, so we do SPDX, CycloneDX, but our customers were like, oh, we want to do more, we want to have specific bespoke reports. Okay, we built it in. We have all of the data. So that was actually a major issue with a lot of the commercial tools. We didn't get all of the data that we need to automate and produce what we actually needed to comply with the contractual obligations that we had. Now I can. So that's it. If anybody has any questions, feel free to ask. Sal, how much time do we have left?
We've got 5 minutes for questions.
5 minutes. Who has questions?
I just want to say thank you. I'd love to hear, because you're about 5 years ahead in thinking than a lot of the OSPOs that I have to advise are. What is like one challenge, like one little nugget of wisdom that you wish you could part off to new OSPOs?
Yeah, we had a discussion on there was a workshop on Friday before FOSDEM, And the one knock that we came to, please don't reinvent the wheel. There are very friendly people like me out there that publicly speak about it, and there's also a lot of OSPOS people out there. It's not easy, not difficult to find us. My email address is literally on my GitHub profile. Ask. But even I don't know everything of running an OSPO. But when I need to know, so over time when I've been doing this, I've been adding value to the community because I'm contributing back. So if I don't know something, I go to IRC, Slack, or Signal, and I say like, this is what I need to know. And funny enough, within usually 20 minutes, I have 4 or 5 answers. Because this is how it works in the open. I contribute back, people know something, and oh, you need to talk to this person. Like, I literally have conversations with people all over the world that I would never had a chance. I actually have now lots of friends all over the world that I would never have met if I didn't do things the open source way. Now, I have to say, like, not in every organization doing things the open source way would work. I help banks, I help more highly regulated, like the government. But just for me, it's always like, yeah, it might not work 100% for you, but take elements forward, especially these filing issues. I'm organizing something called Ospology Live under the to-do group. This is free, it's local, anybody can show up, it requires no membership, and all of the discussion are on the Chatham House rules. So literally, I created it so that anybody can just show up. Literally, I had students walking in, literally that heard about it and bought a train ticket. We had one last week in Amsterdam, and just showed up and just asked everything on OSPOS. Why? Because he heard about it, saw some talks, but he cannot afford to come to a conference like this. And then he heard, oh, it's in Amsterdam, it's free. So they showed up. And I'm pretty certain that he will hopefully pursue a career in open source, which is good for me. More open source is better. Open source is better for all of us. Good.
All right, thank you.
That's it.
Yeah, I just wanted to reinforce the statement at the beginning. Please be nice to maintainers. One thing I always have to remind people is that it's a human being who reads that PR, and specifically those very highly opinionated issues. Yeah, be a little bit more human on GitHub. In the next couple of minutes, we've got another interesting talk coming up where we are going to focus on diversity and security, how they fit together.
Great. Oh, good, you can hear me. All right. Hello, everyone. I'm Kelly Tebow, and I'm excited to speak with you today about diversity and cybersecurity. And one thing I will give you is I like to do interactive presentations, so I have a Slido as part of this, so you will want your phone. And hopefully, I have a lot of info in here, so I'm going to do my best to stick to our time. So just a little bit about me. I'm Kelly Tebow, like I said. I'm a tech enthusiast. Oh, it's still on that clicker. A DEI advocate. I am an insatiable learner, which is part of why I'm excited to be here. I'm also a generalist, which is something that I think a lot of us have a hard time embracing, this idea of not being a specialist, because we think that you have to be a specialist to be the best or to be great. But you actually can know a lot and still have a subject matter expertise in some things. I'm an industry changer. I spent 10 years in higher education administration, which is also why I clicked with the security team when I switched over to tech, because I did risk management. And I always was like, from a physical perspective, from an event perspective, how can we make sure the worst possible situation doesn't happen? How can we remedy against that? And then if something does go wrong, what can we do to respond to it? I'm also married. My wife is back home in San Francisco. And I'm a dog mom to a almost 14-year-old Quezon dog. He's a big, fluffy thing. And that's a big part of, though both those things are big parts of my personal identity. Oh, and I'm a big coffee drinker. I recently went alcohol-free, so now I drink more coffee. I saw this on LinkedIn, and I thought it was really great thinking about the talk that I was giving today. So talking about not just having a seat at the table, who's sitting at the table, what voice do they have, who's actually heard. Because I remember some past situations where I was sitting in the room, but I didn't have a voice. The leader that was leading those sessions very much did not listen to the women in the room. And so I didn't have any power, even though you would have thought by the room that I was in that I did. So let's give some definitions just so we're on the same page. I tried to use ChatGPT to come up with these definitions, but when I asked him, where's your source, it said, well, I just compile a bunch of stuff from the internet. And I'm like, well, I'm a former academic, that's not good enough for me. So I took a bunch of sources and made up my own definition, and you'll find all my sources. I will upload my slides, but I have about 20 sources that are at the end of this deck. So diversity is the various identities that make us different from others. This includes age, national origin, religion, gender, disability, sexual orientation, socioeconomic status, education, marital status, and a host of other things. I know a couple of things that we don't talk about, and this is very personal for me, but body size, not being a skinny person, and the idea of how you show up physically at work. But also neurodiversity is another topic that I think is becoming more of a conversation, and how are we incorporating people whose brains work differently? So equity then is leveling the foundation to create equal opportunities no matter those identities. And then inclusion is, I define it as environments where those who don't fit those historically traditional ideal of the security or open source professional, that they'll be included, respected, welcomed, valued, paid equitably, and given opportunities for learning, growth, and promotion. And then belonging, so I did DEI-BJ, so diversity, equity, inclusion, belonging, and justice. And I'm gonna finish these definitions real quick, but just as an FYI, as I go through this presentation, diversity is how I will use the catch-all instead of saying DEI-BJ, or if I need to use a specific word, then I will, but I'll use diversity as a catch-all. Belonging, then, is being valued in that workplace, in creating positive connections with the others that are there, while also bringing your own true self. So this can include if you have an accent. To some of you in here, I probably have an accent. The way that you dress, your hair, your educational status, doesn't matter if you have a college degree or not, your parental status, your sexual orientation, gender identity, and a host of other identities. And then justice is fixing those unjust systems and ensuring equity in policy, process, and procedures. So this can be pay equity. Do we have a history of paying people different based on their race, their orientation, their gender? Salary transparency, are we open about the ranges? I know I live in California, they just enacted pay transparency, but if you list the range as $100,000 to $400,000, that's not really helpful. Public DEI data, some companies do a great job, other companies just make a commitment and then don't share anything. And then how the company handles harassment and assault complaints. So I spent a long time in higher education, like I said, and they would always brag about how good they were with DEI-BJ, all of it. But I will say that there was a workplace where I filed a gender complaint because of being screamed at and discriminated against, being told not to poke the bear, to stay in my corner, et cetera. And they attribute it when I filed the complaint and had multiple people supporting it. They came back and said, it's a communication issue. So I don't believe in burning bridges, but I did burn that one when I quit, and I said I'm quitting because of the hostile work environment perpetuated by one individual person. So I don't recommend doing that. That was my rage quitting. I've let myself do it once. So now we're going to do Slido. I've talked a lot already. So I'm going to pull up a QR code. You can use the link if you aren't comfortable with QR codes. And then your answers will be anonymous unless you choose to log in and share them. Okay. Uh-oh. One moment. No internet. Well, this won't work if there's not internet. All right. Oh, wait, did it come back? No, that's just showing you my slides. All right, so we're going to skip doing the Wi-Fi part of it, I guess. Maybe you can come work on that. Q, okay. Okay, let's try this one. There we go. Awesome. So there's a QR code if you can grab it. Otherwise, you can go to slido.com and use the hashtag number that's at the bottom. And then I encourage you to go ahead and answer this question. How good of a job is your company doing at recruiting diverse candidates? And I'm going to go into this a little bit. And I thought the emojis were fun. And you can think of the heart eyes is that diverse backgrounds, identities, and experiences, and the crying faces, you have a very homogeneous candidate pool. Cool. All right. Looks like most people. All right, so I think that's actually really good. I'm impressed that 55% are pretty happy with the way recruiting is at your company. And yeah, okay, we did have the one person. I was like, there's got to be someone in here who has a very homogeneous pool. But obviously, everybody in this room thinks that there's room for improvement. And I would agree. When I left education, I took a learning and development role at a tech company because I thought learning and development was where I needed to go for whatever reason. But anyways, I got to support engineering, product, and design, which was awesome because I love technology. But sometimes I'd be sitting in the room with the senior management of engineering, or even like engineering management, not senior level, just any level, and I'd be the only woman in that room, or the only non-male. And not that my presence didn't count, but in terms of people on engineering, I didn't count in that number because I was on the people team. So I think about this, like, how good is your candidate at even bringing people in? So let's go to the next one. How good of a job is your company doing at retaining diverse candidates? So 1 would be departures are quick, and 5 would be organization retains all employees well. What? Oh. Yeah, the ones are winning it, which is really sad. So when, I think back to the example of when I worked at that university, and I left, and I think pretty much everyone I worked with that's a woman has left since then. And also, mostly people of color, too, because it wasn't a great environment for racially diverse individuals as well. But one of the things is, we talk a lot about where are you getting, are you sourcing your candidates from the right places, from more places than you've done before? But then you can get people in the door, but how do you make them want to stay? What do you do to create environments where people want to stay? And I think that's where, for me, diversity comes into play, truthfully, is can someone show up and say, I have to leave by 3 because I got to pick up my kids today, or I need to go to the dentist. So I had a job once in education. I had a 2.5-hour commute. I'd ride with my wife for carpooling for a while. She'd drop me off at the train station. I'd ride the train into the city, get on a bus, and then I'd walk to my office. So 5 hours each day. I had to go to the doctor and just go to the lab and get something done that took about an hour. But I said, hey, can I work from home? Because then I don't have to spend this 5 hours on the train. And at that place, we had accrual times off, but if we used less than half a day, we didn't have to count it. So I never had to count the absence, but I either had to take the day away if I took the full day, or I had to go in for half a day because they weren't flexible about remote work at the time. Now, that was pre-pandemic, so a lot of things have changed since then. But at the time, they made me spend 5 hours so that I could do a doctor's appointment and not let me work at home, so I lost all that commuting time that I could have been working. So ISD Squared said that job descriptions and hiring managers still operate within a box designed by non-diverse individuals who set the bar too high and want to hire people who look different to them, but who they expect to think and act the same way as them. So I did a lot of research around data, and in one of them, from ISD Squared, they did this research on the workplace experience. And this is what it was a small sample size, but they were all focus groups. And so this is what one of the individuals said, was that part of the reason we're not either recruiting more diverse candidates or keeping more diverse candidates is because even if we could open up the box to think a little bit beyond, we're still expecting them to come in and fit this like white colonialist standard of professionalism. So that is, that doesn't really open it up for people who act differently, think differently, speak differently, look differently, et cetera. Do you have to wear, I'm so thankful I no longer work in an industry where I have to wear a dress or slacks and heels. So let's talk about some diversity data. In gender, women in cybersecurity, a generous estimate is 24%. I say generous because they're including people in IT who also do cybersecurity work. So we're not talking about somebody who's necessarily a full-time cybersecurity professional or that's the full focus of their role. That's how they got to 24%. I don't have that's kind of the industry standard number. I can't find one that's more specific. Women in open source, according to a 2021 estimate, was 14%. Now, that's a little challenging because open source and the nature of its anonymity is a little bit harder to track. So they were like, this is our best guess. But the problem is, most of those jobs are entry and mid-level. And I would say that similarly, it's true for women in cybersecurity as well. And then, in terms of non-binary individuals or transgender individuals, we aren't doing research around people who don't fit the gender binary, so I don't have numbers on that. So race, I just wanted to give you some graphics because I figured it was easier than me typing everything out. This is from Innovation Through Inclusion, the multicultural cybersecurity workforce, which was through an ISD Squared research. They commissioned a firm to do it for them. And you can see that it shows compared to the US population and in the dark blue, and then in the light blue is the percentage of cybersecurity workforce. So Like Hispanic individuals, as they defined it, 19% of the workforce, but only 4% of cybersecurity. American Indian, Alaska Native or Native Hawaiian, 2% to 1%. But, you know, and you can see like almost all of them, except for Asian, are disproportionately underrepresented based on their total representation of the workforce. And then we know, of course, that white people are overrepresented in everything, in the workforce, in cybersecurity. And then this other one is focused specifically on Black and Hispanic workers, that they remain underrepresented in the STEM workforce. So I just thought this was interesting. It's from Pew Research, and it shows all jobs, STEM jobs, and then breaks it down. And so cybersecurity could fall under computer science or engineering, depending how they defined it. But you can see that it's, except for individuals who identify as Asian and white, that they're more higher percentage in engineering than in the total jobs, but everyone else is significantly underrepresented. So that was some interesting data on race. All right, so now I've got another Slido. If you didn't close the page, it'll pop up with this next question now that I'm on it. Otherwise, you can put the data in here. And I'm gonna pour myself a little water. Let's say in the past, like 3 years. That's a great question. Because depending on the length of your career, that's going to have shifted drastically. And as you all know, I fall into the yes category. Cool. So 75% have been in meetings with people who appeared to be all men. Now, I say that because unless we're sharing pronouns, and even then that's not a true case, but we don't go around being like, hey, you know, for the most part, we aren't like, do you identify as a man? And have you always identified as a man? So I would say that that's why I use the word appeared to be, because we're making an assumption based on our perceptions. So next one, I have been in meetings at work, and let's say in the last 3 years, that appear to be all people of the dominant race. And so depending where you're from, that could shift. I'm from the United States, so that typically is white people. And I will say the people who are saying no, that's really impressive and a little surprising, actually. Good surprising, but surprising. So I've got about a 70-30 split. So yeah, that's actually better than I thought. I thought there might be like maybe one person who said that, so thank you. And then I believe this is the final question. Have you noticed or heard things that excluded someone who was not in the majority? And it's okay if you say, I'm not sure. And I would use the 3-year parameter again. So I will give an example. When I was fresh out of grad school, I took a job in Southeast Virginia. And I grew up in the Midwest of the United States. I grew up in Indiana, Michigan. It's not that racism isn't there. People just aren't super overt about it. It kind of happened, or I didn't recognize that it was racism at the time. So I'd gone to grad school, I'd learned a lot about diversity stuff, and I wanted to learn more because I realized what a little bubble I had lived in. And so I went to this job, and I remember standing there, and this person I didn't know, but who knew the admin sitting at the front desk said hello to me and not to her. And I was like, hold up. And I turned around, I was like, did they just say hi to me but not to you? And she's like, oh yeah, that person always ignores me. And I was just, at the time I was dumbfounded. Now I'm like, well, yeah, people do that. And it's not right. But at the time I was like, I'd never actually seen something like that. So I was like, oh my goodness. I didn't say anything to the person. I was a brand new grad, I was young, I was naive. And I honestly didn't know what to say. Now I try to be a little bit better about it. So I think that there's, that's one of the pieces is with DEI is how can we speak up at work in a way that feels safe for us. So let's talk about that. And I will say I wrote some of these myself, and others came from that workplace study that someone gave suggestions, or from one of the articles I read that was like, hey, here's how you can help us. So one of the things that I talked about, obviously, sourcing or recruiting. When I was working at, I was at Open Door, which was it's a real estate technology company in San Francisco. When I was there, I would say, hey, are we going to Afrotech to recruit people? Are we going to Lesbians Who Tech or Out in Tech? Like, what are we doing to bring more candidates who don't fit the homogenous identity of our organization? Like, what are we doing to make a difference? And so I would like reach out to our sourcers and be like, hey, are we going there? And then with recruiting, like I actually help them with some interview questions to be like, hey, here's some questions we can ask to like, even if we're bringing in candidates who seem similar, like let's at least make sure that they're people who we want to work here. Pay equity, if you are a hiring manager, if you are on the people team, if you have any access to that sort of thing, if you lead an employee resource group, how is your company doing pay equity? How are people able to know that they're being paid the same no matter their identity? So I'm not saying you can't adjust for location and its cost of living or experience, et cetera, but in terms of identities, there shouldn't be a difference. And I say that, I'm a little biased. I live in the San Francisco Bay Area, so I need to make a higher salary. You can mentor individuals. So you don't have to wait for someone to ask you. If you see someone coming in, you're like, hey, I want to help them and grow in their job and make connections for them and help them. Mentoring is a great way to do that. So that's easy. As long as you're not a brand new professional yourself, then that's an easy, low-risk sort of thing that anybody can do. And I would say, even if you are a new professional, once you get your bearings in the organization, you still can do that. You can help somebody navigate the organization, even if they're more experienced than you in the subject matter. Advocacy and sponsorship, so showing up and bringing someone to the table with you. So maybe you can't physically bring them with you, but if there's an opportunity for a promotion, for a stretch project that doesn't put too much burden on them, but that opportunity to grow and learn and even take on a new challenge, advocating for them. It could be someone who would be great for your organization and you say like, I know this person has transferable skills, I really want to bring them in, and here's why they'd be a great fit for our company, for this role, et cetera. And that's one thing I had in my notes, but I didn't bring up yet, is the idea of one of the ways to diversify our pools is to think about the roles differently than we have. Not having someone who checks all the boxes. And thinking about candidates who are industry changers. So I was one of those people, but what you get when you hire someone who maybe was a teacher or worked in retail or something like that. They've got the people skills. They know how to build relationships. They know how to connect with others. Maybe they don't have the exact technical skills you're looking for, but you can learn those, and especially if they have a good team member that can help them with that, not having to help them learn how to build relationships and collaborate across the organization, that's something huge off your plate. Okay, I have 5 minutes left, so we're going to go through this quickly. Accountability, speak up. If you see something, say something. I know it's a cliche, but it's the thing. There's 2 ways to do that. I'll be real quick. One, if you hear something in a meeting that calls someone out in an oppressive or exclusive sort of way, you can call it out in the moment and say, hey, I noticed this was said. Let's not say that. That excludes this group of people. Don't call out the person that it excluded, but just call out the group. You can also say, like, let's say you heard someone say something and they were overlooked and then someone else said something. You could say, like, oh, I think we missed what so-and-so just said. I want to highlight I want to highlight what she said or what they said, and then being able to bring it back to them so that they can then share a little bit more, and you aren't taking credit for it. You're saying like, hey, so-and-so did that. You can also pull someone aside, say, I noticed this thing, how are you doing? And then follow up with the person who perpetuated something, and one-on-one say, hey, I noticed this, I'm not okay with that. Like, it made me really uncomfortable because. And that's a lot lower risk. Like, they might not respond well, but you're not calling them out publicly, so it's lower risk. Recommend folks as speakers, share job opportunities and resources. This is huge. Introduce them to your network, especially if you know people who are job searching, like, hey, I know this connection. Support others' work and or initiatives. Be sure to lift people up when they're doing great things. And ask people what support they need. And then follow through when they tell you. Okay. A couple other things, and this is, I'm almost at the end here. Pay attention. So how are neurodiverse folks supported? Are there opportunities for breaks to get away from people, to get away from the work, to like flex their time as needed? What's your remote hybrid in-office culture, and does that connect with the people in your organization? Do people with disabilities work for your company? And if so, are their needs supported? And how many people of size are at your organization, and do they get equal opportunities? When I worked in tech, there was me and one other person who were not like skinny. Who gets a voice? Who makes decisions? And so you may not know these answers, but I encourage you to pay attention and to start to notice that. And as far as like availability of accommodations, you can probably ask your HR or people team. They can't tell you who has accommodations, but you could say what's available for folks that come in that need X, Y, or Z. And then Damani said in the keynote yesterday, invite me to the party, teach me your dance, now learn my dance. And I think that was, to me, that was the epitome of what this is like, we're gonna bring you in, we're gonna teach you how to do it, and then I'm gonna learn about you so we can make sure that you also fit and belong. And then, like I said, 2 slides of references, because I'm an academic nerd like that. And then, tying it back to open source, I think open data can really promote DEIBJ. It's really crucial that we share information and that we talk about it and it's open and available. So thank you very much. Kelly Tebow, I forgot to say, I'm the executive director at Secure Diversity, which is a nonprofit focused on diversity in cybersecurity, predominantly gender diversity at this time, because it's just me and another person. And then that's my LinkedIn and my email. So thank you very much.
I am so tired of reading job applications for DevOps that use he, him pronouns. Thank you very much. Do not do that anymore. That's the incredible amount of the assumption of the type of person that does this later.
Yeah.
Thank you so much for speaking.
You're welcome. So they said, you know, job descriptions that include he, him pronouns, totally not appropriate, totally exclusionary. And so stop doing that. And just be really mindful about the job descriptions. I think that's a huge piece. Okay, any other questions or comments? Cool, well, thank you so much, everyone.
Do you want an intro, or are you capable of introing yourself?
tough one.
All right, for the final session of the State of Open security track, we are going to have my idea of a lot of fun. Andrew Martin is going to step up here and show us in real time how to hack a system. Let's do it.
Very much. Okay, hello everybody. Welcome to Hacking Kubernetes live demo marathon. This will be a light speed blitz through lots of Kubernetes flavored attacks and vulnerabilities. My laptop died a catastrophic failure of death yesterday, so I've reverted to a 4 to 5 year old device. I believe everything is lined up, but we shall see. We'll discover collectively. Right, so hello, I'm Andy, CISO here at Open UK and CEO of Control Plane. I've written various bits and bobs over the years. Very, very proud of the book Hacking Kubernetes that I wrote with my esteemed co-author, Mr. Michael Hassenblas. And copies of the book are, in fact, we have some copies here. If anybody didn't get one in the Great Book giveaway yesterday, I believe there are a number of copies with my esteemed colleagues over on this table, 4 copies. So do bum rush the show should you desire one of those. And also it's available as a download for the first half there at the bottom. We do lots of cloud native security things. This is what it looks like. And you can work with us if you think we are credible. And I'll try and disprove that over the course of this presentation. Okay, we will talk about threat modeling Kubernetes, how to hack a thing. We'll go through a number of different demos, and then hopefully, over the course of this presentation, you will see what happens when a supply chain attack turns into a cluster assault with a container breakout and an escalation to cloud account takeover, what not to do with your production services. Multitudinous and unvaried thanks to all who have gone before me. Some of these are other demos that I've done as well. And of course, the esteemed Liz Rice is a huge inspiration for a lot of these things. This is what happens when your security team sees Kubernetes. Raw, unfettered terror. So what is the problem? Someone else's code running in our production clusters. And in this case, it is the 8-bit monstrosity Dread Pirate Captain Hashjack. He wants to run his code in your clusters. This is ultimately what a supply chain attack looks to gain, but it's also what remote code execution enables. And what might he do then? Well, perhaps steal some data, run some sort of crypto mining or crypto jacking, where either data is locked and ransomed back, or we just do the good old Bitcoin or Monero sort of generation stuff, and it's Control Plane's archetypal adversary. This is a pod treasure map straight from the book. What does one do when they have assaulted a cluster and got inside a container? Well, containers are just a microcosm of Linux, but there are additional things added to the container. Of course, things are namespaced. We have C groups, capabilities, wrap the thing, probably by default. We have our Linux security modules, which are our mandatory access control, providing a system call filtering barrier of some description. Maybe they reach into user space to check whether or not we can access a file or perform a certain activity. We also have, of course, the different namespaces kind of divided out here. This is the way that I like to penetration test on client engagements. This and more available in the book, of course. So before we jump into the meat and potatoes of attacking a cluster, first of all, let's think about how we would defend against some of these things and what is the most important thing to do when defending a cyber thing. It is to quantify and qualify the adversary against which it is being defended. In this case, as I say, the Dread Pirate Captain Hashjack is our nefarious adversary. Why is this important? Well, first of all, we want to know who's attacking us, but second of all, who are we in this case? We can see that, for example, a government intelligence agency has a much higher barrier or much more resource to expend in the defense of its digital estate versus perhaps a game startup. And in concrete terms, we're looking at, for example, the NSA hacking tools being exfiltrated and dumped on the internet. Very embarrassing, kind of changes the game in some ways, versus Valve's source code for Half-Life being leaked. very different adversaries. In one case, you have another foreign intelligence service. In the other case, you have an aggravated, spotty teenager. But the outcome can still be reputational damage in whatever way. This at control plane is how we analyze our adversaries. I have considered adding AI ML as a new layer to this threat matrix, but as yet, the capability is not yet developed. Really, probably what we expect in that domain is for permutations of different attacks to be combined and threaded together in a way that we haven't seen so far, because there is, what would you call it? Kind of an unfettered set of, there are no pre-constraints as a pen tester would kind of have their own guidelines. And potentially at some point, we're going to see custom implants and exploits developed by AI systems that humans have not yet developed. That will be very interesting and purely terrifying. But in the case of what we have here, we start off at the top with a Vandal, a script kiddie. Minimum viable cloud-native security is not being vulnerable to published CVEs. If somebody can download Kali Linux or Metasploit or Parrot OS and run the CVEs that are bundled in those distributions against your systems and break in, well, that's probably professional negligence at the very least. We can do better than that because we have the tools and the scanners to get us there by default. We move into motivated individuals, probably a few more skills. If you look at the capabilities column, those publicly available exploits, maybe we can modify them slightly. Maybe we're going to try and get in through a supply chain, which is so hot right now, of course. We get into insider threats. That becomes a little bit difficult. We're looking at organizational separation of duty and privilege, monitoring and logging, all those good things. Excuse me. Then we get into organized crime. So these are our nation-state affiliated groups. Our APTs, Fancy Bear is a good one. There's a lot of work done by Western intelligence agencies looking at how Russia funnels money through Swiss bank accounts. A lot of published research. It's kind of plausibly deniable, gray area, but still linkable, and yes, fascinating if you're into that kind of thing. We get to cloud services insiders. We're talking about the Capital One hack, for example, where an ex-employee used privilege information to get a server-side request forgery into a web application firewall with an overprivileged IAM account, reads an S3 bucket, dumps customer data, poster child for the cloud pwned, and then finally, foreign intelligence services. This is where you might lose some fingers. So ultimately, when there's a physical threat, it is at this point that we rely on the previous layers of controls to not give one person the access to become a target for a foreign service. And then at the bottom, we have HAL from Space Odyssey. Right, next we get to how we model these things. It is far more difficult for a defensive organization because we must check every box. This is right in my beard, or the remnants of it. So we must check every box in order to, I'm just looking at my blue team t-shirts, in order to make sure that we have a full coverage of the things that we're trying to defend against. For an attacker, it is a very different story. An attacker needs to take one foothold into an organization, observe the visible horizon, and pivot to wherever they can find. It is a defender's job to lock down every single one of those endpoints, which is a far more difficult proposition. So we use attack trees. This takes the attacker's mindset and gives a visible path through an attack, or kill chain, as traditionally they were called, maps it to a diagram such as this, and then allows us to cut the branches, essentially, by placing controls over them. A control may span more than one branch. This gives us a few things. First of all, it is a quantifiable log of what we're doing to defend the system. Why is this important? Because maintainers in the future probably want to know when they're shipping a new feature why the security control exists. It also gives the very abstract and often abstruse, unquantifiable security, probably best to use airburners for security, decision-making process, some actual, again, quantifiability. It's a shared taxonomy for people to be able to discuss things, and it makes sense to kind of allay some of the fear, uncertainty, and doubt that comes with the arm-wavy security that often we see in the industry. Finally, it's also often a way to optimally apply controls, because if one control can cover multiple different attack paths, well, then the cost of implementation, the cost of maintenance, and the maintainability of the thing is likely to probably be a little bit easier than individual controls for every single piece that come maybe from a more sort of terrified, defensive fearfulness than sort of strong, well-defined controls. We do training on threat modeling. It is available on O'Reilly Online. We also do it privately, and a lot of that is open source as well. Okay, with that, let's get into the demo marathon. So, what are we going to do? We're going to think like an attacker and attempt not to panic. First of all, code to cloud attack patterns. We're looking to find that vulnerability and exploit the 4 C's of Kubernetes security. We start with the code. This is where our application is defined. This could be running anywhere, frankly. It could be running on a laptop with in the host namespace, or in this case, it's packaged up into a container. The container is the code plus all the dependencies bundled up that it needs to run at runtime. It's a file system image codified as a tarball in OCI parlance. That runs, the invocation of that is kind of the object-oriented difference between an instance or a class and the instantiated object. That runs inside a cluster. Cluster is dealing with our cross-host service discovery, it's our network routing, all those good things, so attachment of storage objects. And then finally, that runs in a cloud or a colo or a data center where our physical infrastructure, the tin, actually sits with whatever layers of virtualization. So we're looking to take a vulnerability in the code, use it to break out of the security controls of a container, which is the process essentially at runtime, then transcend the cluster in some way to attack the cloud. Okay, open source supply chain and processware. What is a supply chain? Anything that we depend upon. So a producer creates something, it is then consumed. Anything that you put on GitHub de facto makes you a producer in a supply chain mindset. Ultimately, what we're looking to do here as the Dread Pirate Captain Hashjack is to get in between Alice and Charlie and drop malware into the build or the distribution or some element of the supply chain. Supply chains are long and difficult to secure, and we've only just realized as an industry. There's lots of ways we can do this. We can go straight for the source code. We can infect an upstream, so SolarWinds style, or we can infect the runtime environment, which is a bit more difficult because there's a lot of trust that we place into the people who run our operating systems. And by that, I mean concretely the people who distribute the public keys of the root certificate authorities that we trust. That is the foundations of communicative trust on the internet. Okay, so for the first demo, we will drop some malware and an application dependency. That will attack the end user device that we're using, which is my laptop in this case. We'll pull this package. The package is the thing that will run the malware. We'll steal some identity, put it that way. Right, so demo number 1. How is that for visibility? That looks okay. Right, so we know that in here, okay, we've got a few things. We have, so this is an NPM module. It would be, I believe, unethical to upload this to NPM, so I'm running it purely locally. And what we see is package.json, an exfil.sh, which looks suspicious, and the dependent node modules that it runs. So if we have a look at the contents of the, hi Stephen, sorry, I'll close that down. Okay, if we then look at the contents of the package.json, right, we see the name of the package is npm exfil. The version is leet in other terms. The description fills us with an all foreboding sense of dread. The scripts, okay, so we've got script test. Now what happens if we try and execute this? So we go npm run test. Okay, well, we've used a bash built in, which is echo. So we know that the contents of that, the value of test in the JSON is being executed in either a shell, in some probably POSIX compliant shell. So we can just run arbitrary code by dropping it into that, that bit of JSON. But what we've chosen to do here is actually execute another script. The only way, we can see it's a pre-install script. So the only way we would be able to test the contents of this for malicious behavior would be to download this separately from npm or to run it in a sandboxed safe environment. My laptop is neither of those things. So what am I going to do? npm install. I'm going to install from the local directory because of, yes, the professional integrity stuff. So what happens? Well, it's downloaded the repo to my local machine. It then decides to run the pre-install hook, hopefully. Yep, still got, there we go. And it's running the exfil.sh script. This is a bad day for me because I've just installed the keylogger, and let's just zoom back up again. There we go. Okay, so this keylogger is ignored by a lot of antivirus. That means even if I've got passwords on my credentials, which I absolutely should do by default, it can still sniff them from my keyboard input and then tie them back, and then that's my SSH key potentially compromised. Monero miner, because it's a little bit, you know, I mean, crypto still exists at least. And my credentials, why are they important? Because this is executing in the environment of me as a user. And as a user, I have to be able to access my SSH key, my GPG key, my AWS credentials. What else might I have in there? Because those things are all supposed to be passworded. Well, actually, if we go into that AWS directory, had I recently authenticated to an AWS account, the OIDC flow takes a session token and it drops it on my local machine, so I don't have to constantly re-authenticate for the duration of the expiry of that token. That means if someone exfiltrates that, they have production access pre-authenticated to my stuff. That's a bad day if I've just been performing production operations, because someone then has temporary access to those places, even if they haven't taken my AWS keys or they're actually sat in a vault as they should be and not on our local machines. Nevertheless, most of the time, this will yield positive results for an attacker. And I'm a version behind of npm. Thank you very much. One down. So what does that mean? That means, so I just realign things, that we ran a backdoored open source package on my developer machine. This is just an npm install. People do this all the time. It is de rigueur for most developers. That pre-install hook abused its local privilege, executing as my user to herd the things that I own and then pick them up, and then it pushes them to somewhere that I can write to. What could that be? Well, a modern version of this might be stick it in an OCI image and push it up to a container registry of some description. It could be put it into a Git repository and push it to GitHub. These are network routes that even corporate firewalls are probably going to have open, because pastebin has been identified as a source of potentially malicious data dumping these days. Install, exfiltrate, or foobar your stuff. Profit. Especially if one of those things is an SSH key to a Git repo. Then people can go and potentially drop malicious code into your supply chain as you. But that's not what we're going to do. We're going to do something slightly different. We are instead going to drop a reverse shell. So what's reverse shell? Instead of me SSHing onto an open TCP port, so IP22, for example, a reverse shell is a connection from the victim host back to an endpoint the attacker controls. In the case of a Kubernetes cluster, of which this is one, we'll see, number one, we snuck malicious code into a target library. It's built. Third-party dependencies also go into that process. The malicious dependency and the developer code are combined into that malicious image. CI/CD will happily build this without Trivy or another vulnerability scanning tool detecting it, because those tools and antivirus tools and malicious code analyzers look for specific patterns. As long as our code, in this case, simple reverse shell, is obfuscated or looks vaguely legitimate in some way, it is very unlikely to get detected. The difference here is that runtime container security tooling is perfectly capable of detecting reverse shells, so we will discuss that briefly later. The payload then runs in a production front-end container because we've deployed it there. And this container performs its usual operation. So it's been Trojanized in inverted commas. And what that means is the entry point of the application will still run, but using maybe an LD preload trick or rewriting the binary to spawn something else in its flow, fires this TCP connection from the victim container, in this case, out to this endpoint, this TCP IP port that I'm holding open. And in this case, I'll do it with an ngrok tunnel from my laptop. And then I'm catching that shell connection, and I then have command and control into the pod. So that glues together a bash shell, and that, as we'll see, gets us into the production infrastructure that we are targeting. Okay, so how do we fix this kind of stuff? Well, 2FA on everything, because if someone can lift those keys from your file system, then they are hosed. Otherwise, plain text credentials, it's simply awful, of course, as we know. So AWS keys are a particularly common one there. If we do care about crypto, hot wallets are a bad thing. Air-gapped development environments, it doesn't really work for most organizations. It is an imposition to expect that from many places. And finally, we consider signing. Actually, signing is only good to prove the transit of information between two endpoints. It says this person at this point in time liked this thing sufficiently to give it a signature, and then we re-verify it on the other side to say, well, yeah, okay, that's the same thing. Checksums will get us some of that distance. TLS will get us also some of that distance. So in the same space as SBOMs, code signing, none of these things are silver bullets. They must be part of a holistic, wider strategy in order to actually engender trust in the things that we care about. Okay, so supply chain reverse shell. We have our trusted producers. They push their things into NPM. As we saw, developer code builds a thing, trusted application, and Kubernetes. Dread Pirate Captain Hashjack is interested in that second phase. Whoops, one too many, there we go. So for these reverse shells, we see that we've exploited the victim's machine by virtue of dropping that implant into the application code. The victim's Kubernetes cluster will then fire that reverse TCP connection to the endpoint that we control. And this is the diagram we've just seen. So we're actually going to do this in a slightly different way via, instead of, like I say, instead of pushing vulnerable code to the internet, I will do it all locally. So we'll do it via a malicious nginx image that we've backdoored. Still going to run a production container, fire the reverse shell, catch it, happy days. Courtesy of the Right Honourable Mr. Duffy Cooley and Ian Coldwater, when they first got together and scribbled on a whiteboard, they put this one-liner together. Happily now, there is also a double hyphen privileged flag for kube control, which is just a ludicrous and banana armor sort of behavior. I don't know how that got shipped, because privileged is the most dangerous flag in the history of computing. It turns off all namespaces apart from the process namespace. It disables seccomp, AppArmor, it gives all capabilities and namespace, and enables all C group, or disables all C group restrictions. So what we're doing here is we're taking a privileged container. We are running NSEnter, which is namespace enter, a legitimate tool used for debugging invading namespaces. We are attaching that to proc1 nsmount. So that is process number 1 in the proc virtual file system. That's like running PS and seeing the number 1. That is an init system, generally. And the namespace is mount. This basically means we're going to start a shell in the mount namespace of PID1, which is privileged. So that's systemd on the host, because we're also sharing the PID namespace. Actually, PID namespace is the only thing that privilege does not enable, but we've also done that manually. And this will give us access to the host, going from misconfiguration to breakout. This should be protected with admission control. Things like Caverno or a pod security standard will get us there and stop this from being exploitable. But Kubernetes is not secure by default because these controls, these admission controls, are not enabled without additional effort. OK, so we'll run this backdoored image, fire the reverse shell, catch the reverse shell from my laptop via ngrok. So there's actually a publicly routable IP, and that gives us our command and control. And we do so like this. OK, so first of all, we will run this ngrok shell catcher, which is one I wrote earlier. OK, so what we've done there, at the bottom, we've got the debug log from ngrok running. That's given us the DNS name of an endpoint. We've pulled we've just looked up the records and figured out that it is this IP address and that port. And then we've used the dev TCP virtual file system. This is only included in bash. It's a virtual file system that maps network endpoints to a file system. This is how most reverse shells are generated. It's ludicrous and bananas. You should not have bash in your containers, because otherwise you're vulnerable to this. It doesn't exist for shell. It's a super easy way to get a backdoor, and quite unfortunate. We're probably on this Kubernetes version. As I said, my laptop broke recently, which is an advanced excuse. Should I have to live debug this? OK, so what we're expecting to see here, this terminal is locally attached to a pipe. The pipe will be attached to the ngrok tunnel. As we know with Linux, it's just going to block until something attaches to the other side. So let's check who we are. Nothing's attached. So that command is now buffered, just waiting to go through the pipe. Let's see if this works. OK, so what we're doing, Kubernetes run, reverse shell, output is YAML, dry run client, image subliminal hack. Then the executable, the command we're running is bin bash command, while true, do no hangup bash. That is going to attach the reverse shell to that bash session, which is the redirect there for both input and output, sleep one, and then just loop. So if it drops, it'll keep on trying that until something connects. Then we've got, we set that out, so we set host PID is true. Again, admission control should prevent this. Then we set the image, set the security context, tee it standard error so we can see what we've written, and then apply that whole line to the cluster. We hope. That looks like it may have worked. Excellent. OK, so what's happened here is we ran this, and this is what we kind of munged and set it together. That got applied to the cluster. It's connected here, and the command that we ran, once the pipe connected, it wrote. So that's my local machine writing to a local pipe that goes up through ngrok, which has been connected to from the big wide internet, and we're now inside a Kubernetes pod. Or we assume we are. What would we do? Well, if we run env, we can see all the stuff that Kubernetes likes to dump in so that we know that that's where we are. But what else can we do? Well, let's just see what processes we've got running. OK, this is a bad day. Because we've enabled the process namespace, we can see all of the other processes running on the host. This is the kubelet node on which the container is running. From here, we know that we can do a reasonable amount of damage because, for example, we can see here container D. Container D is part of the container run process. See there, it's actually running run C. This is like a self-referential, like staring into the mirror for a container. It shouldn't be able to see the tree that gives it its, the process tree that gives it life. So we know that we're in trouble. We can see here that's actually the command that we were running. So we're in the process namespace. We can definitely cause some damage. What else would we do when we're here? Well, let's, by default, check the devices. OK, we can see the hard disks that belong to the host. Let's just, whoops-a-daisy. Oh, I closed it down, rat bags. OK, fortunately, because, hold on, that's the wrong one. Because we, OK, I'm going to have to hide this on the other screen, but let's do this. Yeah, because we've got that, well, because we have this no-hup looping, I can just go straight back in again. Actually, that's not what I want to do. Just run the same thing twice. What I want to do instead is the ncat, which is in there somewhere. What would I do? I will leave this because the point there is that we can break out onto the host. But we're going to do that in a more exciting way with the container breakout. So that's the way to do it via misconfiguration, which is kind of easy. Let's do it with the container breakout instead. There we go. That's a suitable excuse. Right, so what did we do? We ran that backdoored image. We got command and control in the container. I was going to take it one step further, but we don't need to for the purposes of demonstration. And on we go. That is the same thing. OK, so containers and vulnerabilities. There have been a lot of container vulnerabilities. There have been a lot of container vulnerabilities. Is anything ever truly secure? Well, no. There have been hypervisor breakouts. There are air-gapped traversals. It's a matter of risk balance and management. And while we see a lot of vulnerabilities here, actually, do we prefer to have static applications, a static infrastructure that doesn't progress, that doesn't ship features, or do we like to run a little bit faster and understand this risk balance between new features, potentially market competition with other businesses? My preference, of course, is yes, but your risk tolerance may vary, and in that case, use the appropriate tooling for the job. OK, it's not a container escape. It is a process that wants to be free. So what are we going to do here? Excuse me. Right, we start off with what we saw there was the middle path. We had a non-secured pod. We had poor admission control. We were able to misconfigure and deploy a pod, get remote code execution, and break out onto the host, which was incoming. What we'll do this time is take a pod that is properly secured. So it's actually, we'll use a container instead of a pod. We will use a kernel vulnerability called dirty pipe. Now, this is it's not a copy and write vulnerability. It's I'll get to the slide. Sorry, I'm jumping ahead. The point is, it is secured. We rely upon the kernel for protection when we're running a container, because containers are an abstraction around a process. All the processes are running on the same kernel. And so if there's a vulnerability in the kernel code itself, the container is unable to protect itself. This slide is actually out of order because that's the containers are not a security boundary from the Right Honorable Chris Nova. Because the kernel is not a security boundary, sorry to jump around here, I've just misfingered those slides slightly. The point here is that nothing is a security boundary. Ultimately, nothing is entirely secure. And it's a question of leveling our risk tolerance. OK, just to jump around one more time. So what will we do for this container breakout? Well, just as a reminder, within a pod, we are sharing a number of things. We share the pod configuration, the process. We have the network. So the loopback adapter in all containers in a pod points to the same network interface, which is a virtualized network interface that is plumbed through a container bridge, which is like a virtual switch, which then connects out to the host primary adapter, and that's how the networking is glued together. But the process and the mount and the C group namespaces, so the PID and the file system, should be separate per container unless we explicitly share them with a bunch of caveats and security fallibilities. We also have these virtual file system endpoints that the kernel provides for us, dev, which is our devices, as we saw, proc, which is a virtual file system for the process namespace, essentially, and sys, which is our kernel internals, as well as various other things. We do have a time namespace, but it is rarely used. And the user namespace is the reason we should not be running as root. User namespaces are coming, but they transcend the whole everything in Linux. Everything is a file, and ownership and permissions are fundamental to the Linux discretionary access control security model. So user namespaces are a frequent entry point for kernel vulnerabilities and are not used by default. There is a lot of work going on over the years, and there's a great talk at FOSDEM by Akihiro Suda on the latest and greatest there. But that is an implementation detail because we're going to look at dirty pipe. So this allows us to change any file on the host because it takes advantage of injecting code into memory that's owned by root. So the way that the kernel manages memory is memory is either marked as executable or not executable, and it's owned by somebody. So executable memory owned by root, if we can scribble our own bit of code in there, boom. That's what we want to do. That is an attacker's dream, because that bit of code is probably a reverse shell in some shape or form, or it's some form of persistence, or we drop an implant, or we just brick the machine, or we write some shell code, some shell code, or we mess with the bootloader, or any of those things. So this means that when the memory is executed, it has root's permission, even though root didn't put the code in there. So an unprivileged local user can use an exploit that allows it to write into that memory to escalate their own privilege. This is exactly what we're going to do here. There's also this proc self exe bypass. So proc being the virtual file system, self being a secret symlink to the process's own identity. If I'm process 1, that's proc 1. If I'm process 100, it's proc 100. Exe is the executable that was taken from disk and copied into memory to be executed. It is a symlink back to the original executable, which in the case of run C meant that there was a specific breakout where an attacker could write down that symlink that was mounted into the container to overwrite the run C binary on the host, which is owned by root, so the next time that's executed, then whatever implant you've installed runs instead of run C. That was fixed by run C copying itself into memory and basically removing that symlink before running. We can exploit it here because it still exists, and that one layer of misdirection that was introduced for the fix is undone by this exploit, essentially. So what do? We write down this path, we can't patch the first byte because of page size foibles. So we have to write a very small implant, and we do that with some assembly. Okay, so we're going to break out of a container. Credit to my colleague JCP on our OffSec team for writing this. We actually authored this when Dirty Pipe was 2 weeks old, and it was a 0 day at that point, more or less. Not literally, of course, but there were plenty. I mean, there was no embargo on the CVE, so it was dropped to catastrophic international clamor. What shall we do? Let's get in here. So I have a virtual machine instead of compromising my host every day. Also, I need a specific kernel version, and obviously I'm patched on this device. Okay, so first of all, let us make sure that we have, where am I going, a vulnerable kernel version, as I'm sure you can guess. The answer is yes. Okay, 5.13, February the 7th last, oh, it's getting on for, look at that, almost a year ago. What we will do then is have a look at what we've got going on in here. All right, so first of all, we start with the makefile. We are going to build everything. So we're going to build this very small implant. We mess with libseccomp to actually exploit the vulnerability itself. Weirdly, if we put seccomp inside a namespace in the container, it will be used. And I have minus 10 minutes, so I'm going to go backwards from here. And okay, where's my mouse gone? The interesting things here are libseccomp itself is, oh, actually that's compiled, sorry. Let's go the bad libseccomp gen. There we go. It is just voided and empty for every method. So this goes inside the container, and it's used, which is a little bit of a surprise, of course. Let's make the damn thing. Let's make the thing like that. Okay, so we've then created a container. We've compiled our implant, run C small. We have built our malicious seccomp, which is then loaded into the Dirty Pipe C to generate the actual exploits. And we link procself.exe here, which is how things are going to blow up. Seccomp execution is how we get the code, the exploit to actually run. And with that, let's just make sure that we are an unprivileged user. And let's look at the root of the file system. OK, very nice. So now from within a container, we are going to go make run. OK, so sudo docker run breakout container. We've written the payload into memory. We're waiting for the shell. Now, to do this, we have to trigger, there we go. We have to trigger the runC binary to run. It pops a new window, and it did that itself anyway. So now, who are we? We're the root user. And where are we? Instead of being in that container breakout directory, we're now in, oops, let's do that. Run containerd, IO containerd runtime task. That is the file system endpoint on the host in which the container image was unbundled, and the pivot root system call set the container mount namespace to. So that's where the container actually literally runs, although the container abstractions prevent us from seeing that. But we just broke out of the container, so that's where we've been dropped, because that was the working directory that we were in. And you can see there as well, in this directory, we have the configuration of the container itself. This is a bad day, of course. Last thing to check is what am I doing? The process name, the process, of course. And again, there we go, we're out on the host. There is our exploit running. Yeah, so there we go. We've gone from inside a container, we've broken out onto the host. We are almost done. I can do it very quickly, I assure you. So we've exploited the kernel, fired a reverse shell to the container. So we actually did the same reverse shell trick we used across the internet, across the loopback adapter, and then routed the kubelet. This is a bad day. Always rebuild stuff, mutable infrastructure, la-di-da. OK, so what does a container run on? It runs on a kubelet. What do we have? Well, you can see there we've got various things, but we also have temp mounts and environment variables. Those are a way for us to run secrets and mount them into containers, because wherever an empty dir is loaded, that's actually a temp directory, which is a way of creating a virtual file system in memory. So it's fast and it uses memory as opposed to disk. That is how all Kubernetes secrets are loaded. I should probably go back to my notes briefly. Yes, don't multi-tenant data classifications. These are the kittens of Kubernetes migrating between nodes, and they're terribly dangerous, as you can see. Okay, so cloud account takeover. What are we going to do here? Well, ideally, we are going to find some stolen AWS keys and use them to take over a cloud account in short order. Okay, so how do we do this? Well, first of all, we're actually going to cheat by going onto, I forgot to do this earlier, onto the host we were on. So we broke out of a container to get onto a kubelet host. I hope this infrastructure is actually up. That was probably worth testing. Assuming it is, then we will use, very nice, we will use my portable, there we go. So I have this bash collection of tools, of course, that I take with me everywhere, and I can bounce it into various different bits of infrastructure with this SSH enter enable. That's now pasted it into here, magically sourced it, and I've got access to this tool called ksecrets file system dump. He says, hopefully, let's reset that. Ooh, what happened there? Okay, we're back. Let's go there. Cool, okay, so what this does is it examines varlib kubelet pods, which is where all the pods are represented. Everything in a container or on Kubernetes must exist on disk at some point. And it looks for volume types of projected or bound. It's an implementation detail. Let's skip over it for now. And it looks for all of these things. Those things are Kubernetes RBAC mounted. So they're called service counts, and they're mounted in. And we can see a whole list of them here. We've got all sorts of configurations, metrics agents. But what are we actually looking for? That's the slightly filleted version. OK, there's loads of stuff in there. But let's look specifically for AWS keys. Great, I forgot to load them in as the vulnerable configuration. Let's cheat. That's funny, I did think I did that. OK, mystically and magically, we're going to see secrets, hooray. OK, why are these in here? Because people might be pushing to S3 buckets. They might think it's a good idea to dynamically create load balancers instead of creating them statically. For whatever reason, AWS keys exist in people's Kubernetes clusters and really should not. So nice, we have got access to these. What can we do with them? Well, I'm sure you can guess. Let's go back one more time. So we're looking to take over the cloud account with those keys. Let's try that again. Whoopsie-daisy, let's go there. OK, so now what can we do? We load those access keys, and we run the AWS simple token service get caller identity. This will query AWS to identify who owns the keys and hopefully allow us to take things over. Oh, dear. This is a bad day for not the defender, but the attacker, because this is a canary token. What this means is that the defender, who has carefully sprinkled these across their infrastructure, across their end-user devices, across anywhere that they might be stolen by an attacker, has left them intentionally as a tripwire. Now this has been accessed. Their dashboard has lit up like a Christmas tree. I've been identified. These keys have no credentials. And what I thought was a sly cloud account takeover is actually notified. What's the point here? Well, nothing is entirely secure, and intrusion detection works to some extent, but can still be bypassed, misconfigured. Ultimately, canary tokens and honeypots, which is the slide that I jumped to here, he says, yeah, canary tokens and honeypots are the last line of defense. Canary tokens are super useful. You can have them in all sorts of things, in PDF files, at HTTP endpoints. They just released a new one, which actually escapes me, and I can't remember. Word documents, the whole shebang. You can also run honeypots, which, again, nobody should be running network scans inside your Kubernetes cluster. If that crypto wallet service receives network traffic, you know that it's non-legitimate because that is not behavior that was programmed into your application. What next? Kubernetes is vulnerable in lots of different ways. There's plenty of foot guns. It is a generalized tool for plenty of specialized applications. It is possible to lock it down and make it secure, but it does require some effort, lots of things in there. Pod Treasure Map is important. We do this for a living. If you're interested, please do come and see us. There are some books available. Thank you very much for your attention and have a lovely day. I'll take questions if you're not bored, but feel free to go and get a beer. Thank you, everybody, and thank you to Sal for writing the track for the last 2 days.
All right, I think that's a wrap. Whew. Well, thanks for finishing out this track with a little bit of terror. That's always nice to remind ourselves that we can have a lot of, great ideas, but we still gotta, I gotta get my pen testing done. I wanted to say thank you to all of the speakers that have come out from all around the world over the last 2 days on such a short notice to make sure that we could have a cutting-edge, leading-edge discussion around what open source security genuinely needs to look like if we're going to get this done by 2030, in my opinion. Thank you all so much. And as Andy said, go have a beer.